Okay, fine. So let's get started, guys. So like I said, today I will be talking about fine tuning, and in this lecture, I'm not just going to talk about a fine tuning in my local system, but I'll even try to show you that how we can try to do a fine tuning in a real time, right? In a real time with our OpenAI model. Part number one. So in a local, I'm going to show you like a fine tuning, that how you will be able to do a fine tuning based on the LoRa and QLoRa, basically, right? So basically like a low rank adaptation, and then like a quantized low rank adaptation. So based on that, how you will be able to do a fine tuning in your local system. Part number one. Then after doing a fine tuning, so how you will be able to do the inferencing. And the third part is, so once, let's suppose I have created my fine tuned model, right? If I have created my fine tuned file, so how I can make it available into a Hugging Face, means I have done the fine tuning. I'm going to do the fine tuning. It's available in my local or maybe in some other server. And let's suppose I have to make it available for the entire public, so that anyone and everyone in this world will be able to use it. So that is also I'm going to show you. So like a local fine tuning, then pushing those fine tuned model into an Hugging Face repository, so that all of us will be able to use it the way you are downloading a model. So even you are using a Hugging Face and you are trying to download the model, so someone has pushed it over there. So that is something which I'm going to teach you in today's class. Apart from that, so how I will be able to do a fine tuning with respect to a OpenAI. So OpenAI, again, there are like a tons of model which is available in a OpenAI. So GPT like a 3.5, GPT-4, all sort of models are available inside a OpenAI. And we'll try to prepare a data based on the supervised fine tuning or based on the RLHF kind of a fine tuning. So we'll see that how we can try to prepare a data set for such kind of a fine tuning, and then how we can actually do a fine tuning in reality, so that model will be aware about my fine tuned data. Apart from that, also I'm going to show you that whatever model is available, whether it's a Llama, whether it's a Mistral, or any other model which is available on Hugging Face. So how you will be able to do a fine tuning for any model, whether it's a LLM model, whether it's a like a vision model, whether it's a machine learning model, whatever is available on Hugging Face, how you will be able to do a fine tuning based on your own data set. So this class is going to be a complete master class for a fine tuning after today's class. So whatever model that you would like to do like a fine tuning with, I believe you will be able to do it. All model on a Hugging Face without any kind of exception, everything on an OpenAI, and then even in a local based on PEFT, parameter efficient fine tuning, basically. So inside PEFT, there are two components which comes into a picture. One is a QLoRa and one is a LoRa, basically. And I'll be talking about that as well, that what is the exact meaning of this LoRa and what is the exact meaning of this QLoRa, basically. So is it making sense, guys? Yes? Shall we move ahead? Amarath is asking me a question also. What is the main difference between agentic AI and MCP? I'm a little bit confused. See, even in MCP, so we try to like build tools and we try to like make it open. So MCP is technically a protocol, right? For example, what is API? So API is nothing but it's a protocol. It's a set of the rule. Similarly, MCP is a set of the protocol, by the way, that okay. So any application which is going to follow this protocol can be attached to any other application. So people have built a standardized approach and everyone is nowadays trying to adopt it. For example, so far in this entire tech world, inside this entire IT world, you must have seen that every platform is providing API, right? So API is what? API is a standard approach where anyone can look into that API, anyone can call that API by passing credential, by without passing credential, and they will be able to use your product or whatever you are trying to expose via API. So API is what technically? It's a protocol, right? It's a set of rule that, okay, so whenever you are trying to expose this one, this is the path, this is the route that you should follow, this is the set of the rule. Now, similarly, MCP is technically a protocol that, okay, so if you have to attach or if you have to call, if one tool would like to call any other tools, for example, my ChatGPT, for example, my Cloud, for example, like a MCP inspector, or maybe like your any application, right? If it would like to call some other tool, so far with the help of API can be called, right? With the help of API. So with that route, I will be able to call it. Now, So MCP is a set of the rule which has been derived that, okay, fine. So expose that as a MCP and even other is following the same rule. I will be able to attach both, right? So now you can call any agents, you can call any kind of a tools over there. So that's the exact definition of the MCP. Hope I'm able to explain you. This question was from Amarnath, I believe. Yeah, Amarnath. So it's a protocol, by the way. You can call tools, you can call agents, all. Whatever you want, you can call it. Okay, so sir, when we say fine-tuning, is it that we need to optimize the performance of the model on my own data set? I will be talking about it, don't worry. So this class is going to be a master class of fine-tuning, and hopefully this class is going to be our last class for your entire generative AI lecture. So next week onwards, you don't have a class. So I'm going to wrap up this class today. But after discussing about this entire things in a very depth, you can expect that today will go a little bit longer. Maybe like it will take 3.5 hours of time to discuss each and everything. Maybe before that we can try to conclude, but yeah, at least, because in fine tuning, whatever syllabus which I have mentioned, I'm going to cover each and everything in today's class itself. I'll try to show you a demo in today's class itself along with me. You guys will be able to do it. If you want, you can do it parallelly, and you will be able to get the entire experience that what exactly the fine tuning is and what can be done, what can't be done with the fine tuning. Yeah, and how fine tuning is different from RAG. Many people are going to come and argue that we are doing a fine tuning. Can we go ahead with the RAG? Because with the help of RAG, I will be able to, achieve the exact same thing, right? So I'll try to explain you even that particular part. Okay, so let's get started, guys, step by step, one by one. So one step at a time. So we are going to take, and then we are going to understand that how we are going to do a fine tuning. So let me share my screen, by the way. And I have prepared a lot of demo yesterday night. So till late night, I was just preparing all of this, like a running demo for all of you. So I can, so that I can come to class and then I can show it to you. Plus, guys, you need a account of OpenAI. So anyone who is not having an account, so you need an account of OpenAI. So when I have to show you the fine tuning with respect to OpenAI model, right? OpenAI model, all of this model, GPT-3, 4, Turbo, Beanie, Nano, Preview, everything you will be able to fine tune. And apart from that, so you need an account basically on Hugging Face, right? Hugging Face. So please try to log in on a OpenAI. Please try to log in on a Hugging Face. Inside Hugging Face, so I'm going to show you even there is something called as auto train. So where you can go and you can try to select any of these models. So I'll try to show you that how you can try to, create this auto train like models, and then how you will be able to basically like perform those operations. So a lot of things, guys, a lot of things I'm going to like talk about in my today's class. Yeah. Okay. So let's get started first of all with a theory. So let me share my screen. Okay, screen is already sharing. So scribble link, by the way. Let's talk about a theory first of all, that what exactly this fine tuning is, right? What exactly this fine tuning is, and what is a meaning of a PEFT, parameter efficient fine tuning. Inside that, you will be able to get the term called as LoRa. So low rank based adoption or low rank based fine tuning basically, and you will be able to find out something called as QLoRa. So QLoRa means basically it's a quantized low rank adaptation. So what is the difference between this LoRa and QLoRa? And then we'll be talking about I'll try to give you a lot of insights, right? A lot of insights that you will be able to understand even mathematically that, okay, so what is the difference between these two? And from an interview perspective, this is important. If you have mentioned that you do a fine tuning, people are going to ask you the differences. And today I believe I'm going to clarify that particular difference. So guys, see, first of all, what is fine tuning, by the way, right? And what is the advantages that you all will be able to get with the help of fine tuning? Let's try to understand that part. So we have a models, right? We have ChatGPT models, we have a Gemini models, we have a Mistral models, We have models from Perplexity. We have models from Llama series. So we have all of these models, and we all know that these model is been trained on a certain data set, right? Certain data set. And nowadays, the model that we are able to receive, the best model that we are able to receive, so it is having all the knowledges. It simply means that it has been trained on all of those data set. But if you are going to ask a question to this model, maybe with respect to a neuron, right? Maybe with respect to neuron, if you're going to ask a question, maybe those model will not be able to respond, right? If you are going to ask some sort of a question, maybe with respect to your organization, yeah, let's suppose your organization is having a certain policies, certain HR policies, certain finance policies, certain loan policy, right? Certain healthcare policies, certain insurance policies. So those model will not be able to respond because your organization policy is a private, right? Your organization policy is basically private, and it's private to your organization. The data is private to your organization, and model is not aware about that particular data. So if model is not aware about that particular data, then obviously it will not be able to respond, right? It will not be able to respond. Now, so if I want a model to respond based on my data, then what are the approaches that I can try to take? Yeah, what are the approaches I can try to take? So approach number one, which I can try to take, is basically RAG. Yeah, so we have already discussed about RAG, by the way. So approach number one, we have already built a lot of RAG application in a past, in a class itself. So retrieval augmented generation is one of the approach I can try to follow. Now what RAG does? So RAG is going to take a LLM model, that's completely fine. But technically, we try to, when we talk about RAG, so we try to basically store all the information into some of the vector database, right? Vector DB, we try to store all the information, vector database. Now, so whenever someone is going to fire a query, so it will try to do some sort of a searching, some sort of a matching, some sort of a similarity search it will try to do, maybe Euclidean, maybe cosine, it will try to do a similarity search. So let's suppose if I'm going to fire a query, so it will go to vector DB, and then whatever top K result I will be able to get, so I'm going to combine it with my vector DB, and then that will be passed to a LLM, right? That will be passed to the LLM, so that LLM is going to polish it, and then it will be able to give me the formatted response. This is what happens in case of RAG. So if I have to, if my model should respond with my organizational data or maybe my private data, RAG is one of the approach. Yeah, RAG is one of the approach. That's completely fine. But the problem with RAG is that you have to store all of those data into a vector database. Yeah, vector database, and every time, so it will go to a vector DB, it will try to do a similarity search, and then it will be able to give you a response, right? Then only it will be able to give you the response. Now, so RAG is best. RAG is best. So whenever your data is changing frequently, so let's suppose today is this policy, tomorrow someone else is going to come and they are going to change the policy. So if something is changing very frequently, but still I want my model to format it and give me a response, so in that situation, I can go ahead with the RAG approach, retrieval augmented generation approach. But let's suppose since last 10 years, I have a same policy in my company, right? Or let's suppose there is a research paper which I have published, and it's already been published, and now nothing is going to change in that research paper. I want my model to know about my research paper as well. Maybe my model has not seen it. I have published the research paper today, and model was trained till yesterday's data, right? And the research paper that I have published is not going to change. Or maybe the data, the innovation that I have done, the findings that I have done, it is not going to change, let's suppose, right? But my model is not aware about it. Your GPT model, your a Cloud Sonnet model is not aware about it. Gemini is not aware about it. Your LLM Llama is not aware about it. Maverick is not aware about it, right? So, and your data is constant. Basically, your data is not changing. So in that case, what I can do is I can try to follow one approach called as fine-tuning, right? I can follow an approach called as fine-tuning when data is not changing, right? So in the case of fine-tuning, I don't have to involve a vector database. Means whenever someone is going to query, I don't have to hit my vector database again and again and again and extract the chunk and then go for the answering. No. So if my model is already aware about a data, like the data, private data that I have, right? The data that I have. So I can directly go ahead and do the inferencing with the model, right? So after inferencing, the way I'm able to inference the current model. So even after fine tuning, I will be able to inference it. I will be able to get the response. But you should not do a fine tuning where your data is changing frequently. The only reason is that fine tuning is a costly approach. So fine tuning is basically one time, it is going to give you a cost. Means whenever you will fine tune, obviously your GPUs and your CPUs will come into a picture, your resources will come into a picture, and it will cost you something, right? RAG will keep on giving you a recurring cost. As your data will increase, you will try to take a bigger and bigger and bigger instances of vector database, and then you will keep on holding a data inside that. So both is having pros and cons, and this is something which I'm trying to explain you, that RAG will give you a recurring kind of a cost. It's not like RAG will go for a free. No, not at all. You are using an LLM model. So technically you are doing an inferencing, even in case of RAG, right? Even in case of a fine-tuned model, you are going to do the inferencing. In case of RAG, you are using the inferencing of the model plus vector DB. And obviously vector DB is a costly operation, right? It's a costly operation, by the way. And as your data size will grow, so obviously you have to increase the instances, and again the search is going to be the costly operation. It needs a more compute, by the way, in terms of even doing a checking and then trying to find out the similar top K data. So to avoid that, if my data is constant, what we do is that we go ahead with the fine tuning approach. That okay, let's try to train my model, the existing big model, right? The big one, which is already aware about a lot of context, lot of information, with my small data, right? With my small data, and then try to use the same big model for my day-to-day job, right? For my day-to-day job. So this is something called as fine tuning. Now, in case of fine tuning, we can try to go and adjust the entire weight. So when I talked about transformer, right? So I have already shown you in a transformer visualization that everywhere, wherever we talk about KQV, so obviously everywhere we will be having a weight matrices. I hope you remember the attention formula, KQV, based on KQV, right? That I have explained you. So basically, in case of fine tuning, what we can do is, so whatever neural network weights, I'm just going to draw a very simple neural network. So whatever weight that we have, so here we have a weight in between, right? So we can go ahead and we can try to change all the weight. We can tune all the weight. Yeah, that is one of the approach in terms of fine tuning, right? Now, let's talk about a transformer architecture, and let's talk about a 96 layer, maybe a 400 layer, 500 or 1000 layers, right? Layer of such kind of a transformer. Now, the number of parameter will be in billion. And again, we are able to see like a 70 billion parameter model, right? So from Llama itself, even 400 billion parameter model we had. Yeah. So the number of parameter is number of trainable parameter I'm talking about, these weights, right? It's 400 billion, 70 billion, right? Even 1 billion. It's a huge number. So if you will start tuning all of this as per your small data that you are trying to pass, or whatever data you are trying to pass, right? Again, this fine tuning will be a costly approach. The meaning of fine tuning is very simple. Changing a weight, which is adjusted on my data set, or adding some weights over here, right? Adding some weights over here. So which is basically been tuned, or which will be able to understand the relationship between my data, because at the end of the day, any neural network is going to give you an output based on the weights, right? Based on the weights and biases. That's it. Right? Doesn't matter which design you are going to use, because at the end of it's just architecture, right? But at the end of the day, trainable parameters are weight, right? So here, basically, we can go ahead and we can try to change all the weights. That's one of the approach. But this approach is again going to be a very costly approach, because we are talking about a billions of parameter, right? But I hope you are able to understand the meaning of fine tuning. Fine tuning means changing a weights as per your own data set, right? And changing a weight not from the scratch, not from the random weights, changing a weight from a weight where model has already learned a lot. This model has already adjusted a lot. So that's the reason. So we are using a fine tuning, right? Otherwise we can go and we can try to create a model from the scratch. right? But no, we want a previous knowledge as well as we want a new knowledge. We want both the knowledge, by the way, right? So if we want both the knowledge, in that case, obviously we have to train or we have to tune the previous model, the existing, the big model, by the way. Okay, so fine tuning. Now, changing all the weights is going to be the costliest operation, and I don't want to follow that approach. Yes, I don't want to follow that approach, basically. So what approach I should follow where I will be able to tune my model, the big one, with the billions of parameter, but in a very, very efficient way, right? In a very, very efficient way. So then people have derived, basically, for a fine tuning, people have derived an approach called as PEFT. And this is something that you will be able to get all the time. So PEFT. Now, what is the meaning of this PEFT, by the way? So the meaning of PEFT, or full form of PEFT, is parameter efficient fine tuning. Okay, inside the fine tuning. So one approach is I can go ahead and change the entire weight, tune the entire weight. The second is PEFT approach. PEFT approach says that parameter efficient fine tuning. Now, what is the meaning of this parameter efficient fine tuning, by the way? Yeah. So this is just one of the term. This is one of the approach. PEFT is one of the approach, by the way. Now, this is one of the umbrella, you can say. Now, under this PEFT approach that people have derived, so there is something called as capital L, a small o, RA comes into a picture. Capital Q, again LORA come into a picture. And you must be able to heard about this LoRa and QLoRa again and again and again and again, right? And out of curiosity, people keep on asking question that, can you please explain me LoRa and QLoRa? Now, after today's class, you will be able to explain. So under this parameter efficient fine tuning, so people said that okay, we can try to do a fine tuning, but instead of doing a fine tuning of whole weight, which is available inside my model, inside my neural network, what I can do is I can try to choose some parameter, right? Some parameter, and then I'll just try to do a fine tuning for that particular parameter. Not beyond that. Yeah, not beyond that, basically. So then people said that, okay, so if we are going with the parameter efficient fine tuning, then what kind of a parameter? How we can derive the parameter, basically? So then they said that okay, there is something called as LoRa approach or QLoRa approach we can try to follow. So full form of this LoRa is nothing but low rank, LOW, low rank ADAPTION, adaptation. And meaning of this one is quantized, QUANTIZE, quantize, low rank adaptation. Now, what is the meaning of this low rank adaptation then? Yeah, what is the meaning of this low rank adaptation? And what is the meaning of this quantization and quantized low rank adaptation? I'll try to explain you that part as well, right? And even after today's class, you will be able to understand what is the quantized model. So we say that we are trying to build a quantized model which can run even on edge devices. Devices which is having a very small compute, but it is going to run it with that. So after today's class, you will be able to understand even that particular part. So here, the meaning of basically LoRa is, let me explain you with some sort of a mathematical intuition, by the way, right? That what happens with respect to a LoRa and how LoRa efficiently going to adapt it, right? Adapt it. So here, when we are talking about a low rank adaptation, right? Low rank adaptation. So let's suppose we have a model, and inside the model, obviously, we will be having a weight, right? We will be having a weight. So it simply means that we have a matrices. For example, so we have, let's suppose, a 512 cross 512 matrices, which is representing a weight, right? Which is representing basically a weight. We have seen that KQV values, right? So which is representing a weight. Now, as a part of this low rank adaptation, what we are going to do is that we are not going to change this weight. Means we are going to freeze the weight, whatever weight is available here, in this layer and in this layer, I'm going to freeze it. I'm not going to change it at all. right? Let's keep it as it is. Don't touch this particular weight. So this 500 cross 12 cross 512, let's suppose that's a matrix which is trying to represent the weight. Don't try to change anything for this one. Do one thing. Try to derive one more weight, W dash, and W dash is nothing but, let's suppose this is the size of this weight. So W plus delta of W, right? Delta of W. Now this delta W is representing a low rank adaptation. How? Yeah, how delta W is representing? So we are trying to create a new, means what we are trying to say that this is the neural network, right? Try to add one more layer maybe, which with a weight, with the new weights. Try to add one more layer over here with the new weights. This is basically what? This is a delta W I'm trying to represent. So add a new layer of the weight in the neural network itself. Don't touch the existing one which has already been trained. Yeah, delta W. And here when you're trying to create a delta W, try to follow this approach. What approach? Low rank adaptation. What is the meaning of low rank adaptation then? Right? So for example, so here delta W is nothing but A dot B. A dot B. Now what is this A, by the way? So A is going to represent basically like a dimension of the matrices with maybe like a 512 cross 4, and B is going to represent 4 cross 512. 512. So just try to attach this delta W. Delta W is nothing but this particular matrix multiplication. Yeah, this particular matrix multiplication. So where A dimension of A is this, dimension of B is basically this one. So this delta W means one more layer. Try to attach it over there, and we try to take this low rank, a small number, as maybe 4. Maybe we can try to take it as a 8, because so this is something called as delta W is called as low rank approximation for the new layer that we are going to create. So is it making sense, guys? So when we say like a low rank adaptation, what is the meaning of it? And what is the new weight? New weight is nothing but my old weight, means the old weight, whatever weight that we have, plus adding a new layer of the weight at the end of the day. Yep. So technically, in case of a low rank, right? So what is the actual meaning of a low rank? So whenever we say low rank, so let's suppose we have a 512 cross 512 matrices. So total number of parameter will be how much? 262,144. If you are going to multiply 512 cross 512, so this is the total number of parameter for a full matrix, right? Means full weights. If there is a 512 cross 512. Now what we are trying to propose over here, that okay, just try to take 512 cross 4 plus 4 cross 512. Now what is the total number? So this total number will become 4096 basically, and this will be low rank. So we are trying to add this matrices to my existing one, basically, and we are going to tune this one. So this number is approximately 1.5% of the total number that we have, total number of trainable parameters that we originally had in my model, 1.5%. So I'm not training the 100%, right? I'm just trying to create separate. Again, this is not a subset. Many people even get confused, and many people have asked me this question, that is it the matrices that we are trying to derive, is it the subset? Delta W is a subset of W? Not at all. And again, in an interview, people ask this question. It's a very interesting question. So generally people think that this delta W is actually a subset of W, but no. Delta W is a complete new matrices. We are just trying to take an inspiration in terms of a dimension, but not the value. We're not taking any values out of that. Right? It's a complete like a random matrices that we are going to take, and then we are going to tune it based on our data set. The amazing part is that we are only having 1.5% of the trainable parameter as compared to this one. As per this calculation, as my model will change, this is going to basically change, so that my model can be trained efficiently. It is going to take a low memory, and it will be able to do a better generalization. So this is basically called as low rank, guys. By the way, this is how you can try to represent a LoRa. Now, so let's talk about a quantization. So what is the meaning of a quantization in general, right? So whenever we try to say that we have a weight, right? We have a weight inside a neural network, right? Whenever we say that we have a weight inside a neural network. So here I'm saying that weight is 2.33. Yeah, 2.33. Now this weight is 3.48. This weight is minus 5.68. So these numbers are going to represent my weight, by the way. Yeah, weight, by the way. So by default, we are using this number over here. Now this is basically a fractional number I'm trying to use, or like a real number I'm trying to use in terms of computer, because at the end of the day, computer is storing this number, right? And how computer stores these numbers? In 10, in a bits, computer is going to store the number, right? In a bits, computer is going to store the number. Computer doesn't understand this one. I think we all are aware about it, right? Computer doesn't understand this one. Computer doesn't understand decimal, right? Computer only understands a binary. It never understands octa. It never understands hex. It never understands a decimal, right? It always understands what? Only 0 and 1 binary, right? So to store these numbers, we are occupying a 32-bit of the space. FP32, 32-bit of the space, and we are using to store these numbers. Yeah, these numbers, these weights. Yeah, so all these weights are like a 32-bit, right? 32-bit of precision. So where like a 101010. People said that okay, by default we are using this 32-bit to represent this number. So for example, 5.6825889, something like this, right? This long numbers. 32-bit we are trying to use to store this particular number. Now, if you are going to multiply anything 32-bit with 32-bit, it's a huge calculation, because at the end of the day, when multiplication happens, it happens in a binary. We as a human being, we try to use a decimal, right, for a reference, for easy references. But actual calculation on a computer level happens in binary. It never understands decimal, by the way, right? Everything is binary, right? Everything is 0, 1 in terms of computer. So 32-bit we are using, and then we are representing 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 0 with to represent this number inside a memory, right? 32-bit of memory it is trying to occupy. People said that okay, so can we do one thing over here, that we can reduce the number of bits, right? Reduce the number of bits. Maybe we can try to chop off some of the data, and that is something called as what? Quantization. So people said that what if we can try to take a small set of fixed value, right? Take a small set of fixed value, and then that is going to represent, for example, I'll just give you one example, very amazing example to explain to quantization. So let's suppose my original weight, right, which is been represented by using a 32-bit was, let's suppose this one, 0.98. Yeah, so 0.98. I'm just giving you a sample, 1.23, 0.41, and then 2.67, right? This is my weight. Now 32-bit representation. So every number is using 32-bit of space, right? So 32 combination of 0 and 1, 0 and 1, 0 and 1. It is trying to take. Now, so what if we can try to represent this number in a quantized way, right? Quantized way, right? Quantized to maybe 4-bit or maybe to 8-bit. So let's do it in a 4-bit. So maybe 0.98 I can try to represent by using 1110. Yeah, I can try to represent. Why? I'll tell you that as well. 0010 to represent this one, 1001, and then for this 1111 I can try to use. Now what is the meaning of, by the way, 110, 1110? The meaning of this one is basically 1.0. What is the meaning of this? It's minus 1.2. What is the meaning of this? It's minus 0.4. What is the meaning of what 111? 2.6. Now, just tell me one thing, right? After quantization. So this is basically after approximation. Approximation, D, quantization. So meaning of quantization is that just try to use a lesser bit. So for example, I have assumed that I'll try to use 4-bit instead of 32-bit to represent this number, right? And can I say that 0.98 is close to 1? Can I say 0.12 or 1.2 is close to 1.23? Can I say 0.41 is close to 0.4? Can I say 0.267 is close to 2.67 is closer to 2.6? Can I say that, guys? Everyone? Can I say that original, the 32-bit that I'm talking about, this was the original one, right? And then I have quantized it, means I have compressed it in a 4-bit by using a references, and then I'm just trying to like dequantize it, and this is representing this is representing this 4-bit, right? This 4-bit I'm using to represent this one. Can I say that this and this one is close? Means after quantization, after converting 32-bit into a 4-bit, can I say that it's close? It's not same, right? It's not same, but it's close. So can I say that, can I make a statement over here that I'm not losing much of information, much of relation over here? Can I say that I'm not losing much? So even though, let's suppose instead of representing my weight by this number, I'm using this number, this number, this number, this number. So the meaning over here is that I'm not losing much of information. Can I say that? Yes. Can I say that I'm not losing much of information over here? Yep. Weight is same, right? Almost same. The weight that I have written with 32-bit, it's actually same, right? With the approximate quantization as well. So weight is almost same. But what is the advantage? Yes, guys, what is the advantage? Weight is almost same, right? I'm not losing much of information. I'm not losing much of relation. But what is the advantage that I'm able to achieve over here? Yep. What is the advantage, guys? Memory saving. That's the biggest advantage, right? Which is required to run any model on a edge device. So generally, you will see that everyone who works in edge devices, they will be talking about a quantized model. Now, this is the meaning of quantization. 32-bit representation into 4-bit or maybe into 8-bit, right? So 8 times, just imagine 8 times memory I am able to save. And compute as well, not just memory, not just storage, compute, right? So previously I was doing 32 into 32 kind of a calculation. Now it's 4 into 4, 4 cross 4, 4-bit into 4-bit, right? So we are not just saving a memory. Yes, 8 times memory we are able to save. So if model size is like 80 MB, right? Now it just become 8 MB. If model size was 80 MB, now it just become 8 MB, right? 8 MB. There is a huge difference between 80 and 8 MB, right? There's a huge differences. So that 80 MB model, maybe I will not be able to run in my mobile device, but 8 MB model, yes, happily I will be able to run in my mobile devices. And that too without losing much of information. Yeah, without losing much of information. So that is a meaning of quantization, and quantized model, we use it for what? So for all the edge devices, for all the lightweighted devices, because of this reason. This is a very simple calculation, very simple intuition, right? Just because of this intuition, we try to use it so that compute will be less plus memory will be less. Simple. So here, right? So here there is a term called as QLoRa, right? So low rank adoption. Low rank adoption is one of the approach. Now, what is the meaning of low rank adoption basically? So low rank adoption means I'll try to add one layer, right? I'll try to add one layer, but with a small like a matrices, I'll try to add it, right? That is something called as low rank adoption. That low value of matrices I'll try to add, and I'll try to maybe like do the fine tuning, right? Now, what is the meaning of this quantized low rank adoption? So quantized low rank adoption means it will be low rank, obviously, which is coming from here itself, right? But it will be quantized as well. Means whatever weight, because when we are talking about this low rank, when we are talking about even these many number of parameter, right? So in case of low rank, it will be, let's suppose 32-bit, right? FP is equal to 32-bit, right? In case of QLoRa, it will be 4-bit. So can I say that QLoRa, quantized LoRa will be even way more efficient than LoRa? LoRa was efficient, right? So instead of like training the entire like a 2,62,144 parameter as per this calculation, right? Instead of training this many like numbers, we are just training 1.5%, this much. So LoRa was very much efficient. LoRa was very much efficient, right? But even we are trying to make it more efficient by using what? By using quantized LoRa. So where instead of using a 32-bit representation, we can try to use 4-bit, or maybe we can try to use a 8-bit representation. Making sense to all of us, guys? What is the difference between LoRa and QLoRa? And both of this comes under what? Comes under this term called as parameter efficient fine tuning. So now I believe if anyone is going to ask you that what is the meaning of parameter efficient fine tuning, you will be able to explain by giving example of LoRa and QLoRa. If someone is going to ask you like quantization, you will be able to explain. If someone is going to ask you about the delta W, you will be able to explain, I believe. Yes? Is it clear in your head, guys? Is it clear? Yes? And I hope the meaning of fine tuning is also clear to all of you. Yes, absolutely clear. No confusion at all. Or do you have any confusion? If you have any confusion, please go ahead and ask me a question. I'll answer. So I believe after today's class, you will be able to explain just like a story to anyone that what is the fine tuning, and inside that, what is LoRa, what is QLoRa, right? Okay. Now, so this is a theoretical understanding. And I believe theoretical understanding was the only thing which was required. Now let's go ahead and do a back-to-back practical. So fine tuning in my local, fine tuning in OpenAI, fine tuning on Hugging Face, fine tuning everywhere. So from next week, there is a new Gen AI batch coming up. That is basically a hybrid. That is a hybrid batch that I have launched. So not a live classes. I'm not going to take a live classes like for some time. So I have decided that I'll just try to take some like a live interaction with all of you on a regular interval, not as a fixed time, maybe like once in a 2 week or something like that. Those who are the part of hybrid batches. So that, and again, I'm not going to call it in this kind of a setup. So I'm going to give you a Zoom link and people can join so that it will be like a two-way conversation. So that even you can share your screen and you can unmute yourself, you can talk to me, and I will be able to answer in a live session. But yeah, there is no fixed session I'm going to keep for that one. It's going to be like a on-demand kind of a session that I'm going to keep for my hybrid batches. This is the meaning of hybrid, right? Hybrid means like a combination of recorded plus conversation. LoRa will bring down the accuracy, right? Given we are training a few bait and biases. No, LoRa will not bring down the accuracy at all, because the thing is we are not changing the actual weight. We are freezing that weight. So let's suppose if my model is been trained on some of the knowledge, it will be able to retain that. We are not changing that one. We are just adding one more layer. That's it. Yes. To update it with the new knowledge. So LoRa is basically designed for like a training of a model, fine tuning of the model with the new data set. Yeah. Without disturbing the old weight. Otherwise, you can go ahead with the full layer fine tuning. Full layer fine tuning means you are changing all the weights. Means there is a chances that you will end up disturbing some of the previous knowledge as well. If you are going with the full like weight training. For edge devices, QLoRa should be used, but should we also use QLoRa as a normal practice? See, I have already given you the numbers over here. So there is a changes between the number. In actual, it was 0.98. Now it became 1. In actual, it was 1.23. Now it became 1.2. In actual, it was 0.41. Now it became 41. So we are actually changing it, right? So if you are looking for a less hallucination, if you are looking for a better generation, then you should go ahead with which one? You should go ahead with a original one, not a quantized one. Making sense? Yeah. So it's not like everywhere just to save a memory. So, and then no one is stopping you. See, no one is stopping you to, and no one is even forcing you to use all the time like the original one and don't use the quantized one. You can use anywhere you want. It's your choice. But unless and until it is going to serve the purpose, there is a trade-off. You will be able to find out in original one and even in a quantized one. So if it is going to fulfill your purpose, go and use it. No one is going to stop, but there will be a pros and cons. So hope I am able to give your answer. It was a question from whom? Question from Sanjeev was, I think. Yeah, Sanjeev. I think I have already given your answer. Then Rakesh is saying, does LoRa always result a smaller size model? Guys, anyone who can answer? So question is, does LoRa always give a smaller size model? So if I'm going to apply LoRa, will I be able to get a smaller size model or same size model or little bit bigger size model? Yes, this is the question basically. I think it's an interesting one. So Ramesh has asked this question basically. So what is your opinion, guys? Again, I'm going to repeat the question. I think you can see the question in your chat. Ramesh, asked by Ramesh, right? What is the answer? So Ramesh is trying to say that if I'm applying LoRa, will I be able to get a less size model or like a bigger one or maybe like a same size model? Yes, I think everyone is able to understand. Everyone is saying a little bit bigger. See, when we are trying to see, LoRa is a technique, right? Technique for what? Fine tuning. Fine tuning means what? Means trying to give a new knowledge to my model. Now, as a part of LoRa, what we are doing, so I have said that I'm trying to retain the previous weight, right? And then I'm adding, see, I have already added a couple of like small circles, right? So I'm trying to retain the actual weights, means I'm not changing anything, means model size has not, if I have not changed the weight, so model size is same, right? Model size is same. I'm just trying to add additional weights. So model size will increase a little bit. It is not going to decrease in case of LoRa. So LoRa is just a technique, right? Now, if you are going to quantize, if you can use a QLoRa, right? So, okay, again, one question. So can I say that QLoRa, right? Can I say that QLoRa is going to reduce a weight or, reduce the size of the model or keep a same size or increase the size? What is your answer, guys? Yeah. So what is your opinion about QLoRa? I think all of us are able to understand in a chat. I can see that. I'm really very happy about it, that all of us are very much clear. Okay. So what will happen with the QLoRa? So people are saying it will reduce. Okay. Reduce the size. QLoRa, reduce the size. Think again, guys. Think again. Think about it. Yep. When you're answering this question, right? What will happen with the QLoRa? So is it going to reduce or keep it same or it will increase? Tell me one thing. Many people are trying to say that so in case of LoRa, everyone was right? Everyone was right. They said that it will be a little bit bigger. That's correct. Now with QLoRa, tell me one thing. What is QLoRa? Can I say it's a delta W? Coming from delta W, right? Am I changing a W? When I say QLoRa, so see, QLoRa is an approach at the time of fine tuning. And I have also explained you the concept of quantization. I'm not saying that I'm doing a QLoRa, I'm quantizing all the weights. No. Yes, I can go ahead, I can quantize the entire model, right? I can quantize the entire model. Then I will say that, okay, fine, this is the final quantized model. Making sense, everyone? So when quantization is a concept, quantization I can try to use on the entire weight or I can try to use on a partial weight. Depends upon me. Yes, depends upon me. So when I'm saying QLoRa, it simply means that it's a fine tuning, right? I'm not changing the previous weight. That is frozen. basically on a like that. We are trying to add a new layer of weight, but that weight is a basically quantized one. So again, it will be a little bit bigger. Unless and until I'm not going to quantize the whole model. If I'm going to quantize the whole model, then I said that, okay, model size will reduce by 8 times. If from 32-bit, we are converting it to 4-bit, or from 8-bit, 32-bit, we are converting it to 8-bit, right? Lower bits. But in QLoRa, only that layer, which is responsible for adding a new knowledge, right? We are trying to use it in a quantized way. Are you able to understand this? We had a weight. I'm not changing it even in case of a QLoRa. What I'm trying to say is that whenever I'm trying to use a low rank, right? Low rank, basically. So at this point of a time, the weight, because low rank means, again, it's a weight, but a smaller size, right? So the weight that you are trying to take it in a lower bit. So that will be called as a QLoRa. This has not changed. If I'm saying that quantize the whole model, means quantize this weight plus this weight as well, then I'll say it's a absolute quantized model. But again, that's a quantization. That concept will be called as a quantization of the model. But here I'm talking about QLoRa, means fine-tuning layer only. Ramesh is saying, would we getting the link of the Zoom? Yeah, so like I said, it is not going to be the scheduled one. It will be like a random one. I'll just ping in a maybe once in a month, most probably, maybe like twice in a week, so that we can connect and you guys can like talk directly. And then if you have any kind of a confusion in anything, you can go ahead and ask. Otherwise, anyhow, on a platform itself, I'm trying to make sure that everything should be clear. But yeah, so if someone has to discuss something. But with respect to LoRa, QLoRa will be smaller. That layer will be smaller. That layer will be smaller. And yeah, with respect to a LoRa fine-tuned model, QLoRa fine-tuned model will be lesser. But with respect to original model, it will be a little bit bigger. Hope this analogy is pretty much clear. Okay, now let's move ahead and let's start talking about basically a practical one. Yes, practical one. So I have already prepared this entire like demo, and this takes almost half an hour of time to prepare this final output. The like a final output of this entire fine tuning. So I'm going to explain you each and everything that what we are trying to do over here. Yeah. Do we have more kind of these hybrid classes with the two ways interaction? No, in hybrid classes, we have just one way interaction. So like we are going to upload the video, but yeah, we will try to host some of the sessions. So where I will come and I'll try to discuss with all of you. Are we moving to a hybrid model for all the courses? Yeah, we are moving to hybrid model to all the courses. The reason is very simple. I'm going to take all the class. Means I have already created a plan for me where I'm going to record all the tech, all the tech plus interview series for all the technology plus project, hundreds of projects that I have. So this is what I'm trying to do. So with the help, and again, so when I'm taking live classes, it's very difficult for me to get a time to do a recording basically, because my Saturday, Sunday completely goes for a live classes, and then Monday to Friday. So I just have a 5 days of time. So keeping that in mind, so I have decided that I will be launching just a hybrid classes till the time I'm not going to complete everything. Everything means all the technology in Hindi and in English, plus all the interview series like a machine learning interview series, RAG interview series, agentic AI interview series, generative AI interview series, separate interview series, a deep learning interview series, plus at least hundreds of projects. Already 60-70 projects are available, but yeah, so more hundreds of projects. After that, I will think that, okay, fine. Because at the end of the day, we are living in an age of AI, right? For example, just take an example of this class, or maybe take an example of FSDS. It took 6 months of time. Just imagine 6 months of time it took. when we have not even taken the Python classes, Python class was separate, to complete that particular batch. Now, practically for anyone and everyone who would like to get into a data science industry, if person is trying to do a preparation for a 3-month, right, I think it's possible to crack, right? And it is possible to start building an application after 1.5 months of learning itself. No need to go for a learning for a 6 month, right? So because you learn something and then you will start forgetting something in the past. So keeping that in mind, I have decided that I'll try to record each and everything so that it will be available to all of my students for today, tomorrow, or even after a year. It will be relevant. And in this way, I will keep on adding more and more content because now things are changing rapidly. So with that pace, I have to produce a content, and with the same pace, my student is supposed to consume it. They're not supposed to go for a live classes for 6 months, because we all know, guys, that on day 1, day 0, so live classes looks amazing. We always look for the live classes, but we all know about the consistency, right? How many of us are consistent? I can see that in a numbers. Doesn't matter what people are going to come and say that I like live classes. No, you don't, right? You are just looking for a convenience. You are looking for maybe a excuse, right? And whatever is going to give you a discipline, whatever is going to give you a fruitful result, you will always wait opt for that. So live class or like a recorded was never a part of our discussion. The discussion was that content, whether my students are able to get a content or not. The premium one, obviously, the updated one, not the 2-year-old or 1-year-old recorded content. So that's the reason. So I have taken this initiative that, okay, let's launch it in a hybrid mode so that I will make it keep like updating the content all like 5 days, 6 days in a week on the different batches. And like we have OTT of education, right? So none of my students are supposed to buy one single batch or one single services. So whatever you want, even if you want only one thing, you have to go for like a subscription, a whole subscription. And even if you want all things, you have to go for all the subscription, as simple as that. So means everything is available to everyone, right? Everything is available to everyone. So now my objective is to produce as many content as possible. And I believe everyone can't become a mentor. There are a lot of mentors out there. Even like in my previous company, I have built many mentors. So I believe in creating a lot of like people. So obviously I have created so many mentors. They are teaching here and there, obviously, right? But at the end of the day, somewhere I feel that I should go and I should deliver the content. I should go and I should teach, right? As much as possible, at least for next couple of more years. not like after 5-10 years, maybe like, but yeah, at least for next 5 years. So I can teach. And yeah, so now things are becoming very, very interesting, right? The way, like the kind of a development that we are able to see in IT industry, in a tech industry, it's amazing, right? It's amazing. And yeah, it's giving me a lot of learning. So same learning, I'm just trying to share with my students. So keeping that in mind, we have a hybrid batch now, and back to back, I'll keep on launching hybrid batch. So far we have launched, I think 20 hybrid batches in all the segments. Again, 20, 20, 20, 20. So 20 for project, 20 for interview. I'll keep on bringing it. I'll keep on providing you the content. And yeah, along with the services, all the other added services, which is again very much required. And then sometime we will try to connect. Anyhow, we are connected over a WhatsApp group. But yeah, so sometime we'll try to connect maybe via Zoom, and then we can have some sort of a discussion. I think hybrid approach is the best to learn quick and revision to and raise a question when live Zoom. You don't have to wait for, see, in case of Zoom, so I'm not expecting a small question, because for that we have already given you Yuri. Now, no one should come and say that you are not providing a support or you are not giving a hand holding, because you are living in an age of AI. If you think that for your small question, let's suppose you are getting an error, right? If you have not declared a variable, or if you are getting a file not found kind of an error, and if you think that someone should come and solve your error, then believe me, you are not meant for IT industry. You will not be able to do anything in the IT industry. You should look for some different options in your career, right? If you're looking for a person. So those kind of error, you should be able to solve by yourself, by using AI, right? By using AI, basically. That is the reason. So as a part of ecosystem, we have given you Yuri that, okay, don't go outside. Don't like try to spend another $20 per month, which is too much, right? So everything is available over here. Use it, learn it. At the end of the day, the only thing which matters is result. So the Zoom session, so I'm looking for like a big problem. I'm looking for a big discussion over there, right? That, okay, you will come and ask a big question over there. Maybe a big problem statement you will try to put up in front of me. Not like, okay, I'm not able to like, I'm getting this error like a file not found, right? Those days was different. 5 years back when I was running at tech, so we had a big support team, day and night, they will be available. Whenever you are going to ping, they will respond back immediately, right? And I had that team. I had run that kind of like a startup as well, right? Which I sold to some different company. But today environment is different. It's not the same environment you are living into. You should not wait for the people, a person. Don't worry, we'll not leave you. We'll catch you in a yearly subscription. Thank you. I'll try to make it better and better so that you can't leave, even if you want. How about internship? Can someone who is not a part of group can apply? No. So like for an internship, you run plus. Everything comes with a Uran plus. How you keep yourself updated? If that's fine to share from you. See, I keep on building things. My very simple approach is that I build things. Right? I never believe in learning, even till today. Right? If you'll sit with me for one straight day, right? Even like a day when I'm taking a leave, when I'm like off basically from all the work, I just sit in front of system. I build things, right? So that's the reason on a Uran platform, and even in my previous company, you were able to see a lot of like an ecosystem. That's the reason I keep on saying that it's an ecosystem I'm trying to build. So I'm not a guy who who read. I read a philosophy books, but not a technical things. Tech wise, I just build it, and that is the source of my knowledge. I just keep on experimenting it. Okay, now I'll try to answer all the other questions, guys. But before that, focus on the topic first. Okay, let me teach you how to do a fine-tuning. LoRa-based fine-tuning, how to do it. Then how to push this model that you have fine-tuned into Hugging Face so that other people will be able to use your fine-tuned model. Yeah. Then I will teach you OpenAI. So how to prepare a data set for OpenAI, because when you do a fine-tuning for OpenAI or any fine-tuning, any model, you have to prepare a data in a respective manner. Otherwise, you will not be able to do a fine-tuning. So for OpenAI model, I'm going to show you. Then Hugging Face, where you can fine-tune any of the model. So I'm going to show you. So let's go with the demo, and then I'm here. I'll try to answer all of your questions. Don't worry. Yes. So let's try to focus, and I'm going to share this entire file with all of you now itself. Yeah. So that you all will be able to execute it. So here, guys, this folder. Let me share this folder first of all. Okay, so model fine tuning, and let me check what is the size. Okay, it's a 17 MB of a folder. Model fine tuning D drive. So just do one thing. Model. Okay, so I have just uploaded this particular folder, guys. So please try to download this folder. First part. Second part is, so there is a requirement.txt file. I have just done the pip freeze, and then from there I have generated the requirement.txt file. So just try to install a new environment, right, inside your VS Code. I believe we all know. In every class I was doing that. So conda create -n, then the environment name. So just try to create the new environment with Python 3.10. Yeah, with Python 3.10, activate that environment and then do pip install -r requirement.txt. Requirement.txt I have already attached inside that one, so that your environment and my environment is going to be same. Otherwise, it will give you a lot of issues. I have struggled a lot, and then I have fixed all the issues, and then it's running perfectly fine in my system, right? Otherwise, it will give you a hell lot of issue, believe me, and you will feel frustrated. So simple. Create a new environment with Python 3.10, a fresh environment. Inside that, just try to do pip install requirement.txt, and then everything will work. Everything means literally everything is going to work for all of you. As simple as that. Now, come to this file. First of all, LoRa QLoRa.py file. Now, what we are trying to do over here, let me explain you that part, that how we are able to like achieve a fine tuning with the help of this one. Yeah. So here, what we are trying to do is, so we are trying to call all the Hugging Face libraries, simple. And then we are trying to call PFIT, parameter efficient fine tuning. So this library is also available, PEFT, PFIT. Just now we have discussed, right? So parameter efficient fine tuning. Then we are trying to call a LoRa configuration from here and then get a PFIT model, prepare a model, and then task type. Dataset wise, so I'm going to use a IMDb dataset. So basically this dataset is all about a review of the data, right? So there will be like this kind of a data you will be able to see basically inside this one. Let me give you the sample of the data for this. So here inside this IMDb, you will be able to see basically this kind of a data. Here, so there will be like a text, and the text is, let's suppose this movie was not good, and then you will be able to see label. So label is like 10, positive, negative, right? So this is a kind of a data which is there inside this IMDb. If you would like to change this data, you can change it. You can do it with your own data. That's completely fine. Yeah, that's completely fine. And in this format, you have to take the data. Now, this is again a data which you will be able to find out on a Hugging Face. So similar kind of a data you can try to create. Now here, so what we are trying to do is that we are not going to use a label. I'm not going to use a label. Now, what kind of a training or what kind of a fine tuning I'm going to perform? Let's try to understand that one. So here, I'm trying to use this model and I'm trying to train this model for a casual inferencing. So basically, this is a casual language model. What is the meaning of this casual language model, by the way? The meaning of this casual language model is just like a chat GPT, means I'll give you something and then you are going to generate the next one. That is called as casual model. Making sense, guys? So basically casual model training I'm going to do. Now you can ask me a question, then why you are taking this IMDb data? Because in this IMDb data, you have a text, means you have a data, plus you have a label, you have a review. So are you going to use a label while training? A simple thing is no, I'm not going to use it. I'm just going to use this part of the data, not the other part of the data, because I'm going to train my model for a casual modeling. Casual modeling means just like a chat GPT. So I'm going to enter something and then it is going to complete, right? It is going to basically complete. It is going to generate the next tokens, basically, just like a chat GPT kind of a model or any other model that you see. So every model is basically a casual model. We, in a tech term, so we try to like say that as a casual model, a model which predicts a next token, right? So in IMDb data, this will be available, but I'm not going to use this one. I'm just using this part, only this part. Yeah. Now we are going to use a very simple Falcon model, a very small model for a training, because if model is going to be big, obviously I need a big machine. It is going to take, it has taken half an hour. It will take like a days and days, and that too with H100, H200 kind of a machine I need. So I'm doing all this training or like a fine tuning in my local machine. Keeping that in mind, I'm not using a big model. I will try to show you even with the big model like a llama in Hugging Face, right? In Hugging Face, I'm going to show you right after this. I'll give you that demo as well. Now here, so this is the model, a simple casual model I'm trying to use, a chat GPT like model, simple chat GPT like model exactly, right? Then tokenizer and then padding token. So this is the model load that we have done. Then this is the data load I'm doing. Like I said, data will be in this format. I'm not using this label part. I'm just using from every data, only the text part I'm using. So whatever tokenization, whatever data that we are going to take, so we are going to convert that into a token length of 128. As simple as that. Yeah, 128. Basically, we are going to convert it into that particular part. Then once that is done, right? Once that is done, so we are trying to do a mapping of the data with the tokenizer, and then we are trying to basically create a column input ID, attention mask, and the labels. Now, so here, Coming to this particular part. So here we are trying to give a model. Main task is going to start from here. Rest of the part you will be able to find out even a Hugging Face. So major part is going to start from here. So here what we are trying to call auto model for casual LLM. This is the library we are trying to call. Casual LLM means LLM which can try to produce a next, basically, right? Which can try to predict the next one from a pre-trained. From pre-trained means the model which is already been trained. So here model name I'm trying to give. Model name is what? This Falcon model that I have I'm going to load. Device map is auto, means if inside your device, if you have a GPU, it will be able to consume a GPU resources. If you don't have a GPU, this one is going to work even on a CPU, right? CPU, even if you don't have a GPU, it is going to work. Now, trust remote code, true. Now, prepare model for the 8-bit training. So here, what we are trying to do is, so we are trying to say that we will try to, right? We will try to do a 8-bit of a training, 8-bit of the precision training, so that my memory will be reduced, right? So 8-bit simply means that obviously instead of 32 bits, so I'm doing a 8-bit, and 8-bit will be lesser. So I'm trying to introduce a Q factor over here. And then I'm trying to set a LoRa configuration. So I'm trying to say that R is equals to 8. What is the meaning of R? So rank, we are trying to say, right? A rank over here. So at the time of discussion, so I have used rank is equals to basically 4, right? So 4 I have used now here. So I can try to change it as a 4. I can try to change it as a 8, whatever I want. LoRa alpha is 16. LoRa dropout is this one. So these are just a parameter which will go ahead with the LoRa configuration. There are more. You can try to configure more. Now, so here I'm trying to call a get preferred model. So model I'm going to pass and LoRa configuration I'm going to pass. As simple as that. So model I'm going to pass and then configuration I'm going to pass and then model dot print trainable parameter. So all this trainable parameter will be print. And here, so for a model training argument I'm trying to pass. So here the LoRa configuration, right? A LoRa configuration from the original model, whatever model that we had, right? And then here to train the model, whatever configuration is required. So output directory, so where it is going to store all the output in this directory. Per device train batch size 2, grid accumulation step 4. So this is the normal things, right? Normal things that we try to do. So each and everything we are trying to do it even over here. And then we are trying to call a trainer. So model.trainer training argument it will take. And then it is going to take the complete data set. A small data set, 1000 data set I'm trying to pass inside this one. And then trainer.train. So this is going to invoke the entire training step. Now the major takeouts, right? The major takeout from here is for any model that you are trying to train. Any means literally any, which is available over the internet, right? Load the model with a tokenizer, obviously, right? Because whatever tokenizer that model has used, you have to use the same so that you have to tokenize your input data, right? Define the task. So I'm trying to do a casual modeling over here, casual learning over here. So I have defined the task, okay? Prepare the data accordingly because every model is going to accept a different kind of length of this token. Then set your parameter. So let's suppose if I'm trying to do a LoRa. So obviously for LoRa, whatever parameter is required, set that parameter, set a parameter for the model training and then call the trainer. As simple as that. Now, if you will start executing this one, right? So just execute Python LoRa underscore QLoRa .py and it will be able to execute. And finally, it is going to give you these many number of files. These many number of files it is going to give you. So everything will be available inside this one. So this is the complete file for a model. And this is the PT file. As you can see, optimizer for optimizer, this is the PT file. And for we have a PT file. So we have this combined things as a complete model. You will be able to get it. Now I have to test this one. I have to test this one. So how I can test it? So there is a test file I have already attached. So the entire model is available over here, right? The entire model is available over here. Now I have to test it. So let me just remove this part, guys. I have deleted it in a later stage. Yeah. So Falcon LoRa output, just try to keep it only this much adapter path. So basically it is going to call the adapter so that it will be able to do a training, right? It will be able to do inferencing basically. So here what we are trying to do. So in case of LoRa inferencing, so we are trying to load the model from where? My local, right? Falcon LoRa output directory that I have created. So from there I'm trying to load the model and then load a configuration. So I'm trying to load the configuration basically, and then load a base model. So I'm loading a base model over here. As simple as that. From this adapter path, I'm loading a base model, as you can see. So perfect. And then it is loading basically adapter path. So from here, I'm trying to load basically this base model. And then once base model is been like loaded basically, so base model adapter, it's loaded. So we are trying to call eval, and then we are trying to call even a tokenizer, because whatever data that you are going to pass, obviously it should be available with the same tokenizer. And then we are going to call the inferencing pipeline. Now here you can control a multiple parameter. For example, temperature. I think we all know that what is the meaning of a temperature parameter. So basically it will try to increase or decrease the hallucination, right? Model is basically the model that we have loaded, our local model, now that we have trained already. And then I'm trying to give a prompt. So inside this pipe, inside this like a pipe, I'm trying to give a prompt. The movie was absolute wonderful because, so this is my prompt, right? So it should be able to generate a next data. So this is what I was like expecting that, okay, fine. So it's generate a next data. So how much next data I'm expecting? Maximum number of tokens. So in a pipe, I have given that generate 100. Generate 100 number of token next, right? Max to max 100 number of token, next token generated after this one. So now I can try to show you the testing at least, right? So here, if I'm going to like clean it and dir and test LoRa inferences. So Python test LoRa inferences. Now here, so I have given the movie was absolutely wonderful. It is trying to do a inferencing, as you can see. I'm not initiating a training. Again, training wise, like just you have to call Python LoRa QLoRa Pi, and it will be able to do a training automatically if your environment is set. But it will take half an hour of time. So for me, it took half an hour of time. So for you, obviously, it will take more and more with these parameters. Otherwise, you can reduce even the number of parameters. Okay, so let's see. So it will be able to do inferencing, and all this inferencing is happening from my own fine-tuned model with my own IMDb dataset. So see, the movie was absolutely wonderful till this because of the actor in it and the way the story was done. I just love the way it was done. The B-52 are back with a new album and the video with the help of the legendary. So now see, if you look and if you read out this entire things, right, you will be able to feel that it's a wonderful outcome, right? It's a wonderful outcome because the base model that I have already used, it was already trained, right? Although it's a small model, Falcon model, right? But it was already trained and it was good with respect to giving the output. Now, the only matter of fact that I have changed over here is that I have given my own data, right? IMDb movie data I have given, right? Just a review I have given and the data, whatever like a review people had talked about. So we have like given that basically, and now like it is able to like do some sort of a response, and that response is better, right? I'm able to understand the grammar. I'm able to understand all the punctuation. It's perfect, right? So this is the like advantage that you will be able to get with respect to fine tuning, and this is something that we are able to do it. Where you pass a LoRa configuration, I don't see it. Is it? See, LoRa configuration, right? Get preferred model. Here is the LoRa configuration. Model plus configuration, both I'm trying to pass. See? So this model will become, this model variable will become combination of model plus a LoRa configuration. And then we are trying to call what? Inside a trainer, we are calling model. Now inside a model, we have a LoRa configuration plus a base model, both by the way. And then for this model, we have a training argument and the data. Fine? Can it accurately provide the review summaries of the specific movie? Yeah, it will be, obviously. So if that is the part of your data, you can try to print even your IMDb data and then try to check, and it will be for sure. And we are taking only 1,000. Only 1,000. So till 1,000 only, just try to do the cross check. It will be able to provide it in a best possible way. Yeah. So just run this one, guys, once again, and then this is just a template which I have shared. You will be able to now do a training and the inferencing after that with any model. Any model means literally any big or small model. You will be able to do a training, at least for a casual modeling, means ChatGPT kind of a task. Okay, now I'm able to build this entire model. I have shared even like a Jupyter notebook over here. So where you can try to push your like a model, the entire model that you have over here into Hugging Face, so that it will be global and anyone can use it. Yeah, it will be global and anyone will be able to use it. You can share a public link. For example, this is a public link that I have posted. I'm sharing it with all of you and you can check it now itself, right? You can check it now itself. So this is the public link. You will be able to see my name, Sudhanshu Kumar, and Sudhanshu Kumar has pushed this particular model. I think today I have posted it or maybe yesterday. I don't remember. I'll have to check the date. Yeah, 20 hours ago. Fine. So, yeah, I don't remember. Maybe I was doing yesterday. So here is a preparation which I have done. So where this is going to help you out in terms of pushing a model into your own Hugging Face, and so that anyone can access it. Now I have shared my link and now you can try to open up this link and you will be able to access it. Part number one. Now how you can do it, let's talk about that. So here what you have to do is, guys, first of all, go to Hugging Face, basically, and then inside that, go to your account first. Yeah, go to your account profile. So here is the account, here is the profile. So just go inside that one. And then once you will be like here, so you have to create a API. Let me, I just forgot. Okay, setting. Yeah, go to setting. Yeah, go to setting. So go to profile, simple, go to profile first of all. So here, then go to setting and then inside a setting, you will be able to find out the access token. Yeah, access token. Now here I have created the access token about 21 hours ago. The access token which I have already mentioned inside your Jupyter notebook, which I am going to delete it now so that you will not be able to use my access token. Yeah. So I have deleted my access token. So I have already shared. So I have deleted it so that you will not be able to push, because that is the only thing which is required to push anything in anyone's Hugging Face repository. So here you can go and you can try to create a new token. I'm going to create a new token once again. So token name. So maybe like a test or maybe like a Sud, Euron, something like this. And then user permission. So what kind of a permission you would like to give? So I would like to give all the write access, by the way, right? All the write access. So there are a lot of like a permission which has been given. You can try to create a n number of token for you, for your entire team member, whatever you want. So I just have to give a write access of the content setting, all the repo. So I'll just try to do check for repository, but only write access is required, by the way, right? Read access is fine. Write access is the only thing which is required. And then I can click on create token, right? Create token. Now this is my token. Yeah, this is my token. So copy it, done. And once this token is created, what you have to do is you have to come. Yeah. And then here, so token will start with HF. So you have to run this code first of all. So Hugging Face hub dot import login and then login. So this token will be able to understand your account and you will be able to log in immediately. So now if I'm going to execute it, yes, I'm able to log in, right? Immediately I'm able to log in. I have changed my previous token. So you can create your own token. Guys, just do it and let me know yes or no if you're able to create it. So simple, go to your profile, then go to setting and then access token and then one click, create a token. Yes, everyone. So I think a couple of days back, so someone from a group, in any group, someone has asked me even that how to publish something in a Hugging Face. So I told them, I replied to them in, I don't know whether it was your group or someone else. But yeah, I have replied that in a couple of days, I'm going to discuss. So that's the reason I thought of discussing this one. Yeah, because we are now going to tune a lot of models, right? Fine tune a lot of models. So obviously push it inside the Hugging Face, make it publicly available. Even if you are going to create a machine learning model, push it inside Hugging Face. Simple. With the proper tagging. I have requested you. Okay, Dev was, okay. So it was Dev. Yeah, this is what, when I was preparing this material, right? I was not able to recall the group name and the person name. It was Dev, by the way. But yeah, so I was able to recall that statement that if you can show me how to push something into Hugging Face. So I thought, okay, fine, let's do it. Do we need to create a new token in HF? Hugging Face, yes. Hugging Face, you have to create the new token. Create a new token. Click over here. I have given you my token, but I have just like deleted that token. So you will not be able to use it now. So I have deleted this, the previous one. I have created even new for me. So create it. Now, once it is done, then what you have to do is, so adapter path means wherever your adapter is, means wherever your entire model is available. So just try to give that directory, right? And then repo ID. So where you would like to like store this entire thing, right? Where you would like to hold this entire thing, just like GitHub repository, by the way, right? So this is my source. So here in my local system where the model is available now, the entire folder, and then repo ID. So how I will create a repo? Very simple once again, right? So I'll go to this one. I'll go to profile. Yeah. And then I can try to create a, so here I have already created one of my repo. So Sudhanshu Kumar, and just do one thing. I'll just, this repo is not available. So I'll just change this name. I'll just make it as a Sudhanshu Kumar. Sudhanshu Kumar is my basically this one, my username. So your username is must. You have to give a username. So here you will be able to find out your username, or here. So this below one, not the above one. The below one is your username, by the way. Yeah. So below one is a username, by the way. So you have to use this username, and then let me. Yeah. So this is the username slash. Let's suppose if I'm going to give a repo name, Falcon Fine-Tuned. Yeah. So execute. Now, so this is going to my repo ID, and this is going to my, so just change your name, guys. Just change this name. If you have not changed this one, then this repository will be created automatically, but you have to change the username first. So, and then this is your local. So wherever you have the, like a models which is available, whatever model is available. So you are just pushing the entire folder. It never understands this models. Basically, it just understands the file. So folder, it will try to push entire folders. Whatever you are keeping inside the folder, it will be published automatically. Okay. So load a LoRa adapter configuration. So we are trying to like load it, and then load the base model. So loading a base model pre-trained, and then simple model dot push. So this is small operation after loading each and everything. So load a base model and then load the adapter, and then model dot push to hub. Simple, and repo ID. What is my repo ID? This one. Yeah, adapter path, anyhow we are trying to use it, so it will be able to understand that what we are trying to push. So this model object we have created, and then model object dot push to hub, execute, and let's see, it will try to push it. Now it is pushing it. Yeah, and now I'm able to get the new like a Falcon Fine-Tuned. See, Falcon Fine-Tuned. This was the name which I have changed, right? Falcon Fine-Tuned. So just click over here, and this is the adapter.json. This is adapter model tensor. So I'm able to upload adapter.json, adapter safe tensors, which is required for the inferencing, right? Which is basically required for the inferencing. So you can even go and check what is there inside this one. So these two things are required for the inferencing. If you would like to push your tokenizer, you can try to push your tokenizer as well. That's not an issue. Yeah. So you can push whatever you want at any point of a time, and it's available inside this particular repo. Yeah, that's available inside. So model card, you can try to even fill all of this information. So Hugging Face provides you this entire template, right? This entire template, and you can click over here. So for example, my model card is completely empty, right? It's empty. I have not done anything. Just I have pushed the file. So these files are available, right? These files are actually available, but inside a model card, I have not done anything. So those who try to maintain the repository, so they try to edit the model card. So here you can go and just fill like a form, or maybe you can try to create a readme IMD and then update this entire things in one shot, in one go. And people who are, so just update your readme IMD. Otherwise you can try to go in a manual way, your wish, right? And then people will be able to see a beautiful definition, and anyone and everyone who is going to use your model, so they can just go through your repository, whatever you have mentioned, and accordingly they will be able to use it. Is it making sense to all of us, guys? Yeah. So how to maintain a repository inside Hugging Face, how to push a model inside a Hugging Face. Can you also show how can we use this HF model for inferencing? Obviously, I have shown you. Okay, Hugging Face model for the inferencing you're talking about. Okay, in a local, I have shown you, right? Same adapter I'm trying to use. So you don't have to do anything. You just have to like load it, and then with the help of Hugging Face pipeline, and then you have to pass the data. It's simple. In a local, I have already shown you the inferencing. So it's the same thing. Okay, now we know that, okay, in a Hugging Face, how we can try to push the model, just like other people are trying to maintain the model. So see, they are trying to maintain the beautiful documentation. Even for your own model push, and they are maintaining the file version, as you can see, they are maintaining the file version. And then there is a community discussion where people can come and people can start discussing about it. So you have the exact same option. You don't have less or you don't have a more, right? You have exact same option, everything you have, right? In your repository. So you can go, you can try to maintain it. You can do whatever you want. And then you can try to like make it public. You can try to make it private, whatever you want. It's your wish. It's up to you, basically, right? It's up to you. And you will be able to share the model, your created model. So it will be good that if you are going to attach some of the Hugging Face URL in your resume, that I have fine-tuned this model for this particular task. I have fine-tuned this model for this particular task. Now, what kind of a task? So far I have talked about the casual modeling, but very soon today itself, I'm going to talk about other tasks as well. So now you will be able to understand that what else I can do, right? What else I can do except this simple fine-tuning. So just try to like upload couple of models over here, maintain the complete like details of the model, maintain the proper README file over here, right? Ask your friend to download it so that proudly you can say that, okay, my model is being used by 100 people at least. At least 100 people are using my model, because anyone is going to download it, right? You will be able to see like a number of downloads. The Hugging Face is going to maintain it. See, it's going to maintain it. Yeah. So it is going to maintain each and everything, that how many downloads has happened, everything. Yeah, everything. You will be able to see, and otherwise people will be able to see it. So it is going to build your credit, a real one, that yes, I have really worked, right? I have really worked, and there is something which I have produced, which people are using, by the way. Yeah. So this is all about the Hugging Face, where you can try to push the model. Now coming to the next section. Again, I'll come back to Hugging Face, right? Just wait for some time. Again, I'll come back to Hugging Face. But now it's time to discuss something more in terms of a model training, basically. So there are like what and all kind of a training that we try to perform. So here I would like to open up my Scribble link, and I would like to discuss. And again, this point is very much important from an interview perspective. So there are different kind of a training which you can perform. So there is something called as SFT. SFT. Now, what is the meaning of this? So SFT means supervised fine tuning. Yeah. There is something called as, right? So there is something called as like a GT. It's called as generic trainer. There is something called as RT, reward trainer. There is something called as DPO trainer. So it's called as direct, DIRECT, direct preference optimization. Preference optimization. There is something called as ORPO. What is the meaning of this? So basically it's more like a DP one, but basically optimized one basically. So online DP, you can say ORPO. It's called as online DPO, right? Now, so these are the different kind of a training that we try to perform. Now, how does this matter, basically, right? How does this matter, by the way? And which one I'm supposed to choose in which situation. So let's try to understand this part, and then I'm going to talk about a OpenAI model. So to train the OpenAI model, you have to prepare the data first of all. So let's try to understand. It's a very easy concept, but yeah, important one. It's a very, very easy, believe me. So the very first one, the supervised fine tuning, which you are going to do, right? Supervised fine tuning that you are going to do. So over there, so basically all of this training that I'm going to talk about. So basically we have to talk about this training things with respect to a data set preparation. So what kind of a data set we try to prepare in which kind of a training. So with respect to a data set preparation, this training approach has been divided. So let's suppose if I'm talking about a supervised training. Now in case of supervised training, what we try to do is, so we try to prepare a data set, which is basically a text, you can say, which is a combination of instruction plus response. As it's a supervised, right? Supervised means obviously I will be having like an input and output, right? For example, so in case of SFT, supervised training, if you are preparing your data, so you should prepare in this way, which I'm going to show you practically. So here, let's suppose text question is, sample question is, what is AI? Let's suppose this is the question. Then you have to even prepare answer. So answer is what? Artificial, or you can say AI is a text, something like this, right? So now here you must be able to see that we have instruction, means question, and we have a response, we have an answer. So this is called as supervised. This is the data that we are trying to prepare. So text, question and answer, both will be available. So whenever you are doing a SFT kind of a training, so whenever you are going to do SFT training, so you will always try to prepare in this way. How does this matter? Where I'm going to use it? Very soon I'm going to teach you practically today itself. Now there is something called as GT, right? So there is something called as GT. Now what is the meaning of a GT? So here the meaning of a GT, generic trainer, is nothing but, so basically you are going to train the model, right? But it is going to be unsupervised. Unsupervised means you are just going to give a text, a data, right? So here the data will be text. Text means, so maybe my name is Sudhanshu, right? There is no response. It's unsupervised, right? It's completely unsupervised. So can you tell me that the training that we have done just now, is it a SFT or is it a GT? The LoRa training that we have done with the help of IMDb dataset. So is it a SFT or is it a GT? Anyone? Yeah, is it a SFT or is it a GT? Yes, guys. Yes, Santosh is giving me answer GT. Great. Yeah, because what I have done, so I have just taken the text out of this IMDb dataset. I'm just trying to train the model for the casual learning. So which will, Joy is saying SFT. How, Joy? How it is going to be SFT? Although my data, I have already made myself very clear, right? I'm not taking a labels. Although there is a label in IMDb, I have clearly mentioned that I'm not going to take it, right? What I'm trying to take, I'm just trying to take the text part of it. So it will be GT. In case of SFT, I will be having like a input and as well as output, means X and Y both I will be having, right? So that is called as SFT, supervised. GT is basically unsupervised. I think we all understand meaning of supervised and unsupervised, right? Now there is something called as a reward trainer. So whenever you are trying to prepare a data set for a reward trainer for RT, so how your data set should look like, it will be very different, right? So basically the reward trainer model that you are going to train, so it will always try to look for the reward, right? It will always look for maybe like a rank the output as a better or worse, right? Better and worse. So here this is also called as RHFL. So RLHF, reinforcement learning with the human interference. Yeah. So generally we heard about the term called as again I'm making a mistake, RLHF, right? So basically a reward learning based, like or reinforcement learning based a training. So where you can try to give a human feedback. So reinforcement learning with a human feedback, RLHF basically. So how does this happen, by the way, right? How does this happen? How we are going to train this model? And nowadays everyone is doing the same thing. So here the data set, that because everything falls down to a data set preparation. At the end of the day, you will have to pass the data. Model is just architecture, right? So you have to pass the data. So the game is all about a data, by the way. So here, whenever you are trying to like train this kind of a model, RLHF model nowadays, which everyone model is, by the way, almost. So here we try to prepare a data in this way. So we have a text, and let's suppose I am writing over here, Sudhanshu is a good teacher. So this is basically a text, right? This is basically a text. And then along with that, so I'm going to pass a rejected text, REJECTED, rejected underscore text, right? Just to counter this text basically, right? So in some of the subject, he is not good. Yeah. So basically just to counter, Sudhanshu is a good teacher. Now rejected text is what? In some of the subject, he is not good. Yeah. So not good. So is it like a reinforcement? Exactly. I'm talking about the reinforcement actually. So reinforcement learning with the human feedback. So this is the feedback. This is the feedback. The second line which I'm trying to pass is technically a feedback, right? So that basically it will be able to get some sort of a reward learning over here. Now, there is something called as DPO, Direct Preferences Optimization. So how do we prepare a data in terms of a direct preference optimization? So here, basically for this DPO, we try to prepare data, right? Basically, what is the goal of this DPO? So the goal of this DPO is learn basically a policy that prefers a human preferred output. So that is basically goal. So here, whenever we try to prepare the data, so here we'll be having three parameters. So let's suppose prompt, 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 and let's suppose I'm writing, what is a changes in class schedule for Gen AI. Let's suppose this is my prompt. Yeah. So what is the changes in a class schedule for a generative AI? Okay. Now there will be a text. There will be a text, right? So here, not much. It's same, but just changed for a week. So let's suppose this is my text. And then here we try to mention rejected text. So whatever we have mentioned in RLHF. So REJECTED, rejected underscore text. Yeah, rejected text. So are you talking about time changes in Gen AI, right? So here, as you can see, that we try to pass three things: prompt, text, and the rejected text. So here, basically, it's the goal, like I said in the beginning itself, that the objective of DPO training, so direct preference optimization training, is very simple. So it will always try to learn the policy, right? It will always try to learn the policy, so which will be like going a preference to a human output. So human preferred output basically. So here, like I'm just trying to ask like a prompt, and based on the prompt, there is a text and there is a rejected text as well, right? So based on the question, it is going to give me answer. And then while giving an answer, it will also try to like check that whether it falls in the rejected text or not. So here, now, so this one is going to be much faster than RLHF basically. So this one is basically like much faster than RLHF that we will be able to find out in that one, in the previous one, RT. Now, there is something called as online DPO. So online DPO, what it does, so same as the before, not very different, I would say, right? But yeah, so it will be like a faster to like a update basically. So it is always going to work with the streaming data, as simple as that, right? So basically it has been optimized for the streaming data, and it is always going to work for the streaming data. That is something called as ORPO. Now, why I talked about it, and where these terms are going to come. Now my handwriting is very bad, guys. I'll try to prepare the entire document and then upload. Today I think it's worse. I don't know why. Yeah. So these are the different like a type of the model that we can try to train. Now what I will do is I will try to go to platform.openai.com. So please go to platform.openai.com. If you don't have an account, please try to create one. Yeah. So just go to an OpenAI, and here, so what we will do, so go to your dashboard, by the way. So inside a dashboard, you will be able to find out one tab, one section called as fine tuning. Yeah. You will be able to find out a section called as fine tuning. Now here, you can try to call all of these things with the help of APIs, part number one. And then you can do a fine tuning. Otherwise, OpenAI is providing you a dashboard. So from a dashboard itself, with the help of UI, you will be able to do a fine tuning. And I'll show you how to do a fine tuning quickly, right? Quickly, how I will be able to do a fine tuning. So here, click on this fine tuning and then click on this create. So click on create. Now, once you are going to create, you have to select a method. So which method you would like to prefer? So see, supervise, DPO or RF. This is something which I just talked about. Right? So what is the meaning of a DPO? What is the meaning of a SFT? What is the meaning of a generic? Or what is the meaning of basically reward trainer? So basically RLHF, right? So whenever you are trying to go ahead with the training, so let's suppose if I'm doing a supervised, so I should prepare a data as per supervised training. If I'm going for the DPO, I should prepare a data as per DPO. If I'm doing a RLHF, so I should prepare a data as per RLHF. That's the reason. So I talked about those things, right? And again, you just have to like know about it. Again, data preparation wise, you can prepare it with the help of like couple of lines of a code. Yeah. So here you can try to, I can select a supervised. Now here you will be able to find out almost all the models, plus you will be able to find out the model which I have fine tuned. Yeah. All the list of the models. So I have fine tuned some model, and on top of that, again, I can fine tune. That's completely fine, right? That's completely fine. So I can like find all the models. So I can try to like, fine tune any of these models, which is available over here with respect to supervise. With respect to DPO, so again, it is going to give you the list. So with respect to DPO, only these main models are available. With respect to RLHF, so only this model Omni is available, right? Omni is available. Apart from that, none is available. Now, this part is important because accordingly you have to prepare the data. Whatever data based on that you are doing a fine tuning, you have to prepare that data accordingly. Otherwise, it will not work, means it will not work. Very simple. So base model. Okay. So here I'm going to take maybe like a Turbo 3.5. Anything I can take. Anyone maybe like I can even like a train 4, the latest one. I can try to train it. So maybe Nano, Mini, whatever I want. So maybe let's take Nano. Yeah. Then suffix. So here I can try to give a name. So my TRAINING training. Okay. Now seed random, sub random number, just try to place it over here. The major part is a data preparation, and see, it is trying to look for what? JSONL file. So JSONL file you have to provide, then only it is going to work, and that too in a proper format as per your method selection. If you are not doing it, it is not going to work. You will not be able to do a fine tuning. So I am doing a supervised, right? I am doing a supervised, and I have already discussed what should be the type of the data. So I'm doing basically SFT. By the way, I'm doing SFT. So I know that there will be an instruction, there will be a response. So in this manner, I have to prepare the data at the end of the day. And then I have to save my data with an extension. Again, with the extension JSONL. So this is what I have done. Let me show you that part. So here is my data, as you can see, guys, right? Here is my data. So I have prepared my data the way system will be looking for, right? So here content, what is AI, right? And then I'm trying to like give a content. So AI stands for artificial intelligence. It refers to the machine that mimic the human intelligence and perform the task. So question, answer, question, answer, question, answer, question, answer, right? So in this manner, I have just prepared the entire content, and then eventually I have saved this entire content, right? Entire content. So see, here the role is user and the role is assistant. So user will ask this. So this is how it will be able to understand that it is supervised. So this is question and assistant will answer. User will ask question, assistant will answer. User will ask question, assistant will answer. So in this manner, we have to prepare the complete data set, and this data set, unless and until you're not preparing for this, it is not going to work, right? It will reject all the time. And many people get confused even over there. So here I have prepared the data set, and then that is the first part. Then you have to save it in a not JSON, JSONL basically. So in a JSONL format, you have to save this particular data set. So I'm just giving you this data. So let's take this data, right? I have already pinged you inside your chat box. So you can take this data. Now save with any name. Name can be anything. Data or your name, my name, doesn't matter. Extension should be JSONL. Always, right? Always. As per the instruction given over here. So I can just click and then I can try to upload a data. JSONL 3 KB file. And one more thing. Minimum 10 data is required. Minimum. Less than 10 if you are going to pass, again it will fail. Yeah. Minimum 10 data is required. So here JSONL, and then I'm going to upload it. See, my data set is uploaded. Yeah, my data set is uploaded over here. And then my previous data and this data is same. So because of that, it is like giving me this one, like select existing. So I have already uploaded the same data, right? Because of that, it is like giving me this one. Maybe I can try to show you by creating new file. So new file, data1.jsonl, and in data1, I'll try to like take this one, and maybe I'll try to copy couple of more. Yeah, couple of more record. So data1.json, and I'll try to like now upload new data1, and now it will show you here. Yeah, so select it. I think, yeah, it's been uploaded now. So no, I'm not going to use anything. Configuration parameter. So batch size, you can try to customize it if you want. So if you would like to change the batch size, you can try to control it. I believe we all know what is the meaning of batch size, by the way. So auto means automatically it will choose. Otherwise, you can configure it. Learning rate multiplier. So you can again configure this one. So in most of the cases, range will be this to this, right? Recommended. Now, so you can keep it in auto. Number of epoch for which you would like to train this. So you can try to control everything. So whatever that for that you write a code, everything you can do it just by selecting this component. That's by selecting this component. Now, once this is done, click on create, right? Click on create. And if everything is good, data JSON it has taken. So it will start validating the file, whether this file is as per your SFT or not, supervised training, fine tuning or not. If it is not, then it will go give you immediately the error. And if everything is fine, then in that case, it is going to start training the model. It will not take more than 2-3 minutes of time. I have a very small data and I'm training it on a like an OpenAI resource itself. So it is not going to take more than 1 or 2 minutes of time, but obviously it is going to charge me. It is going to bill me basically. Now I got the meaning of SFT. Yeah, supervised fine tuning, by the way. So are you able to do it, guys? Anyone who is doing it with me? And can I say that it's very easy to do a fine tuning? Now you can do a fine tuning with any of your data set. Yeah. Just take any data set, maybe your finance data set, maybe your HR data set, anything, right? And pass some sample of this data set to maybe a Yuri, and just ask Yuri that, can you please try to give me a script which can read this data and convert it into this format? Means a format which I can use for a supervised SFT for my GPT. Yeah. So what it will do, it will try to give you the script, Python script. So doesn't matter how much data you have. Maybe you have a tons of data, right? It will be able to prepare and just pass the data, and you can do the fine tuning, and then you can go and show it to your manager that, okay, this is the new model, take it and just ask any question that you want. Yeah. So see, fine tuning is happening, and 2-3 minutes it will take. So see, fine tuning job started, then validation, then matrices also. Yeah, the beautiful part is it will show you the graph. I'll show you, just wait for some time. Yeah, it will show you the entire graph curve. It's paid or free. Obviously, it is going to charge you, this OpenAI. Why you think that everything should be free? So like I said in the beginning, I think I talked about same thing in my previous class, that generally we never hesitate to spend thousands of rupees for partying, or maybe giving a gift to a girlfriend or some XYZ things. But when it comes to learning, I have seen that people even hesitate to apply their card on AWS. And then they think that they will be able to learn the real thing. It's not going to happen. So if you're a serious learner, at least spend $5-10, right, on these platforms. Because the kind of a learning that you will be able to get will be a lifetime, and those investment of $5 or $10 will give you $1 million return. But the investment that you are doing on your girlfriend, maybe on a party, I'm not saying that don't do it. Do it. Obviously, that is also important. So obviously, as a human being, you have to enjoy a life. You have to chill out, right? Because this is how we human works, right? But if you are compromising with $5-10 on AWS and then GCP, or taking a Azure subscription, taking a OpenAI subscription, then that's not good. Then you are not a serious learner. Yeah. So now you can see it's still training, and now we have a graph. So loss is decreasing with respect to my data. Loss is decreasing. Accuracy is increasing. Still, it is into a training phase. Yeah, still it is into a training phase. So just wait for some time. Fine tuning, right? And my model will be available. I can consume my model just like a GPT model, So just I have to change my model ID. I have to give a model ID of fine-tuned model. Yes. So now, as you can see, accuracy is almost tending to 100% on steps. This one, train accuracy, and loss has decreased down to this one. Still fine tuning is going on. So anyone guys who is doing it with me? Anyone? Not even a single? That's sad. Because these are the real-time stuff basically. So if you can, because whenever you will go for an interview, you will mention these things, that I do these kind of things on a regular basis. People will be amazed and they are going to hire you. Otherwise, then things will go in a different way. So now, successfully, right? Successfully file validated, moving job to a QA state, validated training, this, created fine-tuning job. Now everything is done. I can click on playground, right? I can click on playground and I can even try to test it. Yeah, I can even try to test it. So see, this is my fine-tuned model, FT GPT-4 Nano, right? This is my fine-tuned model. By the way, I can try to maintain my temperature. I can try to maintain maximum token, each and everything. And then I can start chatting with this one. And maybe I can look into my data, the data set which I have given. So data set was, what is a black hole? What is a Newton's third law? Summarize the water cycle. Yeah. Maybe what kind of water cycle? I don't know. Summarize the water cycle. Maybe I can ask this kind of a question, which was available. And here, this is the response. So summarize the water cycle. A water cycle includes evaporation, condensation, participation, and collaboration. Water moves continuously through this stage. And now here I can give a human feedback as well. That's good. Okay, tell us what you would like to respond. How? So this is a response that I'm getting from my fine-tuned model. Yeah, and here, so I can try to even give a system message. This is my own model, right? This is my newly created fine-tuned model. So I can try to give I can try to set a tone. I can try to set a tool uses, a response style, that what kind of a response you should give at the end of the day, detailed one, a short one, whatever, right? So see, user is asking this question and assistant is giving this answer. Now go and check. So so what was the answer, by the way, for this one? The water cycle include the evaporation, condensation, this, and water moves continuously through these stages. Yeah. Continuously move through this stage. So yes, it is able to understand. It is able to like give you an answer. Summarize a water cycle. Now, what is water cycle? This question was not available, right? This question was not available. Now, the water cycle is a continuous movement of a water on earth, including the process like evaporation. So see, now it is able to change the format. This was not the exact question, and this was not the exact answer which was available. So my model is able to do a fine tuning, and as a part of fine tuning, it is able to understand like my context. This is the one, and this is from basically what? So this is basically from your GPT, the original one, right? And this is from my fine-tuned one. So I'm able to see that yes, my fine-tuned model is able to understand the context, and based on that context, it is able to give me the answer. So my fine-tuning is now successful. Can I say that, guys? So Mohit is asking me a question that, sir, I wanted to know, how do you know the data you are using in fine-tune GPT-1 nano model is similar to the data on which model is pre-trained, so that after fine-tuning it perform effectively? Okay. So basically, guys, see, there is a document you will be able to find out for any models, right? Obviously, you have to go through a document. Now here inside a document, if you'll come down, so there is a fine-tuning tab. You have to follow along with that. Now see, here they have, I talked about SFT, right? I talked about a DPO. I talked about RFT. All these things are mentioned over here. Plus they have also mentioned, if you will come over here, supervised fine-tuning, right? Supervised fine-tuning. So you will be able to see that they have also mentioned the data format. See, data format. Yeah. This is a different data. I have taken different data, but format is same. Yeah. Format is same. So you have to go through a documentation. That's the reason. So whoever is going to release whatever model, they release a proper documentation as well. Yeah, they release a proper documentation, and we as a techie, we always try to follow the official documentation. That okay, fine. So this is like a format. Whenever I'm preparing it, let's prepare it on that way. So hope I'm able to make your give your answer. So Eric has sent me trained method supervised this. Okay, so great, Eric. You are able to do the training. Amazing. Amarnath is saying, also the network interruption earlier, consider this, I'm going to work in a medical related task and I need to prepare the data. In the medical domain, there are various categories such as this, to provide the labels for, see, Amarnath, this is what I was trying to teach you, right? That if I'm using SFT, right? If I'm using SFT, then what is the data format? If I'm using a DPO, what is the data format? And if I'm using a RF, then what is the data format? That's the reason. So I have explained you this one. So it doesn't matter for which domain you are working. The things which matters is what kind of a training you are doing. Okay, great, Eric. Amazing. Got it, Amarnath? Doesn't matter whether you are training it for oncology or dermatology or anything. What kind of a training you are trying to do, model will try to understand. See, for model, text is text. Simple. Whether it's coming from your this department, that department, doesn't matter at all. It's just a text. It's a LLM, right? Just a LLM. So it is not going to bother your departments. Technically, it is going to bother the kind of a training that you are going to do. And accordingly, you have to prepare the data. So for SFT, I'm showing you. And for all the other format, I have written that, right? For GT, this is the format. For RT, this is the format. For DPO, this is the format. For ORPO, means online DPO. So this is the format. Yeah. And same thing you will be able to find out even inside the documentation. You will find less over here, by the way, right? I talked more. So because they are giving you only 3 options, but technically there are more options. Got it, Amarnath? I'm able to answer your question? Yeah. So for reinforcement, again, what kind of a data it is going to take? They have given you the data side. See, this is the data, sample data they have given you, right? So I will be using this one. And this is coming from my discussion that I've done. Okay, not an issue. Yeah. Thanks, Amarnath. Okay, so I'm able to do a training, as you can see, and I'm able to do a testing as well, right? This fine-tuning model, I'm able to do a testing, and maybe I can try to save it, basically. So name and descriptions are not a prompt, by the way, right? And I can try to create an API, and then I can try to consume this model. I can try to host this model anywhere I want. because this is my now own private fine-tuned model on GPT. As simple as that. So likewise, I can try to train as many things as I want. Now let me check how much consumption, how much like money it took. So billing, how much balance I have? Oh, it has not even taken like a cent, I would say. So it was like a, so I had like $350 in my account in morning, and I think yeah, so $348 only, which is like $2 consumption, not much. Yes. So users wise, I can go and check the users, that what was the actual users like. Yeah, it was very less. June 8 today, so $1.25. Not much. So only 100 rupees, around like 110 rupees. So this is the only thing that this is the only like a kind of a money it takes, guys. Only 100 rupees, right? To see something in real. And if you're not doing it, simply means that you are missing a big part of the life, the real life, right? So I recommend everyone that at least try to invest 100, 200, 500,000 rupees, because we all do that kind of investment on like unnecessary things. So do it here as well. It will give you like some fruitful result. In general prompt, we also give some example and ask the question referring to the example. That example are also kind of fine tuning as well, right? Yes. Yeah. Now, so this is done. So now we are able to understand that how we can do a fine tuning supervise. Now, similarly, you can go with the direct. Similarly, you can go with the reinforcement learning. Now we know that how to prepare the data set and all these things, right? So now any given model, you will be able to train it, right? You will be able to train it and then you will be able to consume it. So this is your model, fine-tuned model. So you will be able to train it and you will be able to consume it at any point of a time via the APIs easily. Now coming to the next part. So this is all about the OpenAI. So whatever model is available in OpenAI, but none of the model which is open source by other organizations are available in OpenAI, right? None of the model which is open source are available on OpenAI. Then what? Then how I can train it, right? So obviously one approach is this one. I have told you, right? By code, by using this code, yeah, by using this code, I can try to do a fine tuning. But you can come to me and you can ask me a question that I'm a manager, I'm not a techie guy, but still I have a data, right? I have a data and I would like to do a fine tuning. So can you suggest me some like a platform apart from OpenAI? Because yeah, in OpenAI, click, upload the data, done. I can get the model easily, right? But do we have any platform so where I can do a fine tuning of a Llama model, a Mistral model, maybe like a DeepSeek model? Yeah, all the open source model, big or small. So so maybe you are not a techie guy, you don't understand this kind of a code, right? So without writing even a single line of a code, will I be able to, because with code, it's possible. I've shown you, right? So if it is possible for one, it will be possible for all. Doesn't matter which kind of a model you are like going to use it, right? Someone is saying go for RAG. I'm talking about fine tuning. So without writing a code, how I can do a fine tuning? Except OpenAI. So here I can do it without writing a single line of a code, right? So even I can do the same thing, exact same thing, even by writing a code in my local and by calling the API of OpenAI. I can do that as well. Now, so there is a platform where you don't have to write even a single line of a code, not even a single line, but still you will be able to do a training. And that is available on where? Hugging Face. So there is something called as Space, right? There is something called as basically a Space. So just go to Hugging Face, click on a Space, right? So they have given you a space for image generation, video generation, text generation. So a space is nothing but a kind of a task. And for that task, there is a template which is available. Image upscaling, data visualization, voice cloning, text analysis, object detection, and then like a document analysis, image captioning, visual, chat bots. So these are the different kind of a space which has been given to you. So there are tons of a space which people have already created. Yeah. Now, what I'm supposed to choose, which kind of a space I'm supposed to choose. So Azure AI Studio, yeah, that's true. You can use Azure AI Studio as well. So even AWS has a service for that. So you can choose. So you can choose any of these cloud platform where just plug and play, and then as a manager, you will be able to train it. And you're not supposed to be techie. You just have to get the data. That's it. And you will be able to like train and fine tune your model, and then anyone can call it, right? Now there is a place even inside the Hugging Face, as we are talking about Hugging Face and we all are aware about Hugging Face. So let's go ahead. I'll try to show you something, right? And it's the best one, I would say, better than I would say like Azure AI Studio and AWS for model training, at least. Not for all the tasks, but yeah, especially for model training I'm talking about. Maybe you can host it over there, but yeah, Hugging Face is the best. So here you can try to like a search for auto train. Auto TRAIN train. Yeah, you can search for auto train, by the way. Fine, you can try to search for auto train, and then just try to copy, or maybe just click on new space. Click on new space, right? And then give a space name. Give a space name over here. So maybe I'll try to give a space name as a training HF. This is the space name. Short description I'm not going to give, right? And then Docker 7 template, Agila, Mario, evidence. Even I can deploy a Streamlit tab over here. Even I can like call this one static, or this is going to create the space. Let me do one. Just go in this way, by the way. So come over here and just call for auto train. Yeah. So here you will be able to find out the multiple template which other people are using, right? Auto train template. So just try to click on any. Any means any. Now someone else is using this one. Object detection transformer JS. What is this space? Auto train. Auto train for LLM. Unreal Engine. Auto train machine learning. Auto train. Advanced. I'm just looking for template. LLM. Sorry, yeah. So my bad, I believe. Auto tune. No. I have already created it, this auto train, as you can see. So auto train. I have to search for. I've already done that, like just trying to show you the starting point of this one. Auto train, and then search for auto train projects basically, and then try to replicate this auto train advanced. So this auto train advanced, you can try to like click on this one, and then it is going to ask you to duplicate. Means someone else is running that. You can't use it. So basically you can duplicate it so that it will run for you. It will run in your instances. So just duplicate it. So auto train duplicate. And now here is the main thing which is going to start. So space name auto train advanced. Let's suppose I already have auto train advanced. So I will give 1-2, right? Auto train advanced 1-2. Now visibility, public, private, whatever I want. If public, then everyone will be able to see it. Now here they are giving you the hardware. They are giving you a free version, and in free version you will not be able to do a training, by the way. You can just initiate the training, and by the time I'm going to initiate the training, it will fail. You will be able to see it in some time. Means I will be able to initiate the training, but it is going to eventually fail. So here by default they are giving you two like a core CPU and 16 GB free one, right? But again, it's not much, at least for training. They are giving you all kind of GPUs as well. So T4 small, and then like there's this. And it is giving you even NVIDIA 100 large, right? The biggest one, which is going to cost you like a $4 per hour. But yes, 142 GB of RAM, and then 12 V-core CPU, and then like it is giving you 4 into 810G large as well. So this is the heaven, right? This is the heaven. This is something that we all need while doing a training, right? Access of the resources. Now, this is not the only platform which is giving you GPU. There are hundreds of other platforms. So they are giving you just A100, right? There are platform which is giving you like a H100, H200. So all those series they are giving you, right? Prices are going to vary, but yeah. So let's suppose I'm going to pick for like a free as of now, and then I'm going to click on duplicate space. The only thing which matters in terms of a model training is this one, a hardware. And the second thing is data. If you don't have resource, if you don't have a data, you will not be able to do it. If you have a data, if you don't have a machine, a powerful machine, again, you will not be able to train the model, right? So here, click on this duplicate space. And now it will take some time to like start spin up my space, by the way. And then I'm going to show you the magic. Done, guys? Are you able to follow along with this? Yeah. So anyone is doing it? Anyone is able to like build the space? If not, just use this link, click on this link, duplicate it immediately. So anyone? Okay, successfully install auto train advanced this. So it is trying to prepare my entire space basically for training. So everything will be done by Hugging Face. You don't have to do anything. See, everything has been done by Hugging Face. Yeah. Now close this and then sign in with the Hugging Face, only one click. So it will be able to do a sign in, then authorize. Yeah. And now this is the panel. This is the auto train panel. This is the panel which I wanted you to see, right? This is the actual panel. So where you can do a training without even knowing a single line of a code, and you will be able to control all kind of a parameter, even more parameter than OpenAI, right? More parameter than OpenAI, you will be able to control it. I'll show you that. So parameter mode, I'm going to select it as a full. So now all kind of parameter. Now let's see. So first of all, task. What kind of a task I'm doing? So SFT, online DPO, generic or DPO or reward. Now here we have more task as compared to OpenAI. This is what I was talking about, guys, right? This is what I was talking about here. So SFT, then GT, then RT, then DPO, then ORPO. So this is what I was talking about. So fine tuning wise, inside of fine tuning categories, we have this 5 categories, right? This 5 categories. In OpenAI, these 5 categories are not available. Now VLM, right? VLM fine tuning wise, I can do that as well. Now sentence transformer wise, I can do sentence pair classification, pair scorpion, triplet, question answering. Other text task, so text classification, text regression, this. Image also I can try to fine tune. Image model also. Object detection model also I can try to fine tune. Tabular task also I can try to fine tune. So not just LLM. Yes, LLM, we have 5 categories of fine tuning, right? So either we can go with the like a supervised fine tuning, or maybe we can go with the DPO, we can go with the reward learning, we can go with the generic one that we have done so far, right? So we can go ahead with any of this fine tuning approach. That's completely fine, right? But apart from that, there are other type of fine tuning also we can do. So let's suppose if I'm going to select SFT, right? SFT. Now project name, anything. Now see how many models are available. Now just imagine any models, Llama, Quen, Mistral, Shravan AI also. The Shravan AI, the recent launch from India, right? Shravan AI, DeepSeek, right? Name any model, guys, name any model. And everything is available just on your click for a fine tuning. Every model is available for a fine tuning. So for SFT, this one, then what and all model are available for DPO. So again, this will change. These model list will keep on changing, right? This model I can select Quen, let's suppose, right? I can select Llama. So for Quen, all the parameter I can control. So all this parameter that maybe you have not even heard about, right? Yeah, this is basic. Basic means only the small parameter it will try to showcase. So chat template, then distributed backend, mixed precision, optimizer, so Adam, SGD. Now this is going to give you the clear learning that, okay, these many parameters even exist, right? These many parameters even exist. This is something that I can try to tune full, right? This is something which and this is something that you should talk about in your interview or in front of anyone, that, okay, I have trained this and I have used this one, and this is something that you should investigate. If you would like to see all the parameter in a JSON file, these are the parameter, and it's editable. You can change it. You can change it basically, right? You can change it. So now copy this one, put it into the URI, ask it that explain me all the parameter with respect to this model. It will explain you. And again, in all the models, it's going to be almost same, right? So at least for once, if you're going to understand, it will be amazing. It will be amazing literally, right? So these are the parameter. So I can try to choose like a base model from here, right? I can try to choose basically any base model based on the task. So let's suppose if I'm going to do a SFT task, right? I'm going to do a SFT task. Now here data set, I can upload it from my local. Yeah. For a SFT task, I can try to upload a data set from my local, or I can try to be even take a data which is available inside Hugging Face itself. Because in Hugging Face, we have a huge data, right? So with Hugging Face data, if I would like to train something from local, just simple drag and drop or upload. From Hugging Face, if I have to use some data, so I have figured out for SFT, there was some data. Yeah. So there is a no robot data which is available, I believe. No, this one is for SFT. This one is for SFT. I can use it, right? So maybe open bev text 10K. Let me copy, right? So let me copy this data set. So just this one is required, which is available on a Hugging Face. I can try to give like no IMDb. I can't. This one I can try to give. I'm trying to do what? SFT. So for SFT, what is the data set which is required? So accordingly, I have to give the data set, then it is going to work. I don't remember. I'll have to check again, but yeah, let me go ahead with this first. Now column mapping text, fine. And then start training. So yeah, sure. If success, yeah, see, success, monitoring your job in local, and it will fail immediately. It will fail immediately, right? So I'm able to submit my job, as you can see over here, but because of so the space has been paused by its owner. This issue you are going to get because you are running in a free mode. You don't have a sufficient a memory for that kind of a model that you are trying to use. That is the reason. So this is the issue it is giving you. Now you can go to setting. You can try to even choose over here, upgrade it. So as of now, this is my mode free, right? A basic one. I can try to choose anything that I want, which is available over here. And then I can try to relaunch it. Everything I can control it from a setting. Yeah. But the main part which I'm trying to show you from here is that I'm able to submit my training successfully, right? I'm able to submit my training successfully. So auto train advanced, I'm going to click it, restart this space, starting again. So it will follow the same loop because it got terminated because of overload. Successfully installed auto train advanced. Yeah, that's amazing. So are you able to do it, guys? Are you able to do it? Let me give you this data set link as well, just for the submission. There are so the best way is to take your own data. Yeah. So the best way will be to take your own data, and that's the reason. So I talked about this, that for SFT, how to create the data for this. So how to create the data. So just try to create that kind of a data and then pass those data. Okay. So this one is again up. So again, if I have to do a DPO, if I have to do a SFT, if I have to do a generic training, so I can try to select any model which is just at my click. I can try to maintain any of these parameter. I can tune any of these parameter, and then I can try to train it. That's a power of Hugging Face auto train, which you will not be able to find out anywhere. And that too in this easiest way, right? So even for object detection, right? There are so many models. It's a computer vision model, by the way. So all of these models, right? So that is the main advantage you will be able to find out, where you have a proper UI, proper compute you have. So at your a disposal, so you can try to take any of the CPUs and GPUs and start doing a training, train the model, and then you can try to even host the model. So that's the beauty of Hugging Face space. That's the reason so Hugging Face is getting so much of popularity. Is it making sense, guys, to all of us? And I can, if I don't want to use a Hugging Face resources, so what I can do is I can even try to do each and every kind of a setup in my local. And by using a Hugging Face API, so I can try to do the fine tuning, which I have done in the beginning itself. Yeah. So if you don't want to go ahead with the Hugging Face paid one. But yeah, you just pay for per use. So again, it's not going to charge you for more than that, because on an hourly basis, they are going to give you the GPUs. And again, the best part is you don't have to do any configuration. Yeah, the best part is you don't have to even do a configuration. If you're going to take a bare cell or bare metal or bare GPU, so obviously you have to do a configuration. So again, you have to write some sort of a Linux command, but here, nothing. So model is also available over here. Dataset you can upload directly by click. GPU is also integrated in this one. So everything in one single package, basically. So it's an ecosystem, I would say. So ecosystem of model training. So hope all of you are able to understand it, guys. And can I say that it's very easy to do a fine tuning, right? If you understand what task you are doing, if you understand what task you are doing and what kind of a data you have to prepare. So can I say that model fine tuning is literally a very, 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 very easy task? Yes, everyone. Can I say that model fine tuning is one of the easiest tasks? Generally, people get scared that how I will be able to do a model fine tuning. It's a big model, this, that, right? A buzzword. But look at this. Look at this OpenAI and I look at this code that we have written today, right? It's nothing. It's very easy. It's very logical. So now you can go ahead and you can do a fine tuning. And now what I want you to do is that in your resume, next time when you are going to update your resume, so try to derive a context that, okay, so for healthcare industry, for like a finance industry, for this, that. And if you're not able to get some idea, ask Yuri. Yuri will give you idea. And try to mention that I have fine-tuned this model on H100 GPU. It took 5 days of time for me with 10 GB of a data or 5 TB of the data. Build this kind of a story. Yeah, build this kind of a story and mention that story into a resume and then talk about that story in an interview. Yes. And then see the magic. You will say, wow, you know a lot of things. Let's like join my company, just join my team, right? So you have to build a story and then you have to sell the story, as simple as that. And all these things can be done. See, nothing is hard. Like according to me, if you'll ask me like what is tough, I never say like tough is just a state of mind. So nothing is easy, nothing is hard. It's just like you have to pay attention for some time. That's it. If we go to launch the Hugging Face model as a teamwork in local, then how I mention all the members' name here. So they are giving you this editing page, right? The very first landing page. Over there, you can try to mention all the contributors. So they are giving you option. So all the contributors you can mention. Yeah. So hope all of you have enjoyed this entire session and we are able to cover everything from your, where is this? Okay. So I'm able to cover everything from your syllabus, by the way. Generative AI with so hope as a part of this syllabus, now coming to a conclusion, guys. So now look into your syllabus of fine tuning and then tell me whether we are able to talk about everything or not. Introduction of fine tuning, model optimization, this, then fine tuning. Prefect, parameter efficient, LoRa and QLoRa, we are able to understand. Then how to do a fine tuning with the GPT model by preparing the data set, performance optimization, hyperparameter, everything. Then how to fine tune any model, Llama, Mistral, whatever, Falcon, based on that to task, right? So like a fine tuning of free models, Hugging Face, we know, advanced fine tuning approach, so RLHFs, everything we are able to discuss. So almost everything we are able to cover except like small like things. And yesterday I have given you the task to build this project. So a couple of people have pinged me and they have pinged me with their link, live link of a render, and they are able to complete the task. I'm assuming that you all will be able to complete the task because now we know what is tool, what is agent, how to deploy it, everything, right? Everything and all the frameworks. So it's just a matter of fact that how many things you are going to build and then how many things you are going to write it into your resume. So coming to a conclusion, guys. So this is officially a announcement for all of you. So this is a final class, official. Obviously, we all are connected over a WhatsApp and I believe you have the entire batch access. So obviously I'm assuming that you will try to avail all the features like books, projects, and whatever is available on Euron, right? Whatever is available on Euron, including Yuri, like resume AI and everything, even job portal. But officially, this is an announcement for all of you that this is the last class. This journey of like 4 months, I believe, March, April, May, June, 4 months, I believe. Yeah, February, March. So this journey was amazing. Okay, 8th March we have started. 8th March was the first date when we have started. So March, April, May, and then now it's June, right? So 8th, okay, amazing. It's 8th June, exact date. So hope this journey was wonderful. Hope I was able to teach you a little bit, at least. You are able to learn a little bit. Okay, multi-model. I have already prepared that example. Maybe I'll send it to you. Just run it and you will be able to understand. So multi-model means I was trying, like I have the example which I have prepared. So where I have prepared a LangChain plus a Gemini. So Gemini will try to basically extract all the information from the images, and then in a middle, so we are going to place basically a LangChain with the models, with the LLM access. I'll share that like with all of you. You can run it, and it's a simple Python code. You will be able to understand, not a very lengthy one. So I believe we all are now able to understand that what is generative AI, what is agentic AI, what is RAG, what is fine-tuning, what is the difference between all of these, plus a framework, right? So whether it's a LangChain, whether it's a Llama index, whether it's a LangGraph, whether it's a Crew AI, and along with that, a core concept, a transformer, right? A core concept, the core NLP concept. So hope we all are able to learn. Here and there, obviously syllabus is very huge. It's like so many number of lines I have mentioned as a part of the syllabus. So maybe 1 or 2 topic here and there. Obviously that's pretty much obvious that maybe I have not discussed, right? But majority of the topic, the major topic, I think we have already discussed, and I believe all of you are able to understand it. Now the next step for all of you to work on the project. Now from where you will get the project? So internship portal I have created. Finally it's launched. And inside internship portal, in a very, very structured manner, PRD, project requirement document, HLD, LLD, the document which you will be able to get even if you are going to join the industry. So everything is mentioned over here. A lot of projects are mentioned over here. A lot of domains are mentioned over here. If some domain and some technology is not mentioned, you have access to give a request. So you can request for that, right? But try to do a project from the internship portal, even if you're the experienced person. The reason is very simple, so that you will be able to understand how delivery happens. First part. Second part is a structure you will be able to get. Because when you build simple POC, MVPs, you don't get that structure. But when you solve the real problem in a step-by-step manner, right, a structured manner, then you face a lot of different kind of challenges. And now that challenge will make you a real techie. And that challenges are going to help you out when you will go for the interview. A next one, right? So that is the next step. At least try to do 1 or 2, not for the sake of getting an internship letter, because internship letter is very much important for dropout. Internship letter is very much important for a fresher. Without that, like it's like technically impossible to get any kind of opportunity. But for an experienced person as well, it's my strong recommendation that pick one of the project, maybe a medium, maybe the hard one, right? And then of domain of your choice, simple, right? Go search the project, and if it is not available, raise a request from there itself, right? In the dashboard itself, we have given you that option, raise a request option. And again, that don't expect that it will be available overnight. It takes time even for us. So we are having a limited resource, a limited number of like a team member. Will take 10 days, 15 days of time. But yeah, if it is feasible, again, not all the project will be done, not all the domain will be uploaded. If it is feasible, then obviously we are going to like make it available. Yeah. And hopefully it will be. In 99% of the cases, it will be available. Maybe in 1% case, we'll reject it, will not upload it. So that is something that we are going to do. Then the next step is go for the interview. Start applying for the job. Start preparing the resume. Start fine-tuning your resume parallelly, and start applying for the job, and keep on building now onwards. Whether it's a RAG application, whether it's a agentic AI application, whether it's a fine-tuning, right? Keep on building. Never afraid about a framework. See, today some people are talking about some framework. Tomorrow again some framework will come. But now we are in a position, we have seen enough, right? We have seen enough where any new framework, just go and touch any new framework. Just go and explore any new framework. Believe me, you don't even need me or someone else. You will be able to explore and you will be able to use it. And I believe that kind of understanding we already have, theoretical as well as in a practical manner. This is something, this is how we have like taken and we have like driven the entire batch basically. So just prepare for the next step, guys. That's my advice. And I'm available in your WhatsApp group. Now it's time to take some question. User has covered all the project in MLOps in the first project of this course. MLOps in the first project of this course. No, he has not taken even a single class here. So he has taken one class in FSDS, and over there he has discussed the MLOps. And even like you will be able to find out complete brand new MLOps from him. So that course is also available. And even over there, project has been discussed. You will be able to find out multiple projects inside the, if you'll go and search in a project where MLOps is been implemented. So, and again, a new batch is coming from my side. But again, you don't have to wait for MLOps, a new batch, for my batch especially. Even that one is a very good one. And you can go ahead and start from today itself. Yeah. Now, Joy has pinged me this one. Okay, let me check, Joy, what you have like a pinged. Some render URL you have pinged me. You can keep on asking question, guys. Now I'll answer your question. I'm reading out all the comment one by one. Thank you, Revaju Amazon content. Happy to be the part of this batch. Really feeling confidence in the face of interview in the future. Build it, Amarnath. Build. And believe me, no one will be able to beat you. Imtiaz is saying really wonderful journey. Thanks a lot. Need to revise a video again and again. Okay, that's great. Hope you are able to explore and learn something, Amarnath, Imtiaz. Amarnath is saying, is MCP is mandatory to learn nowadays? See, MCP is not very different. Just go and do one thing. I'll advise you. So there is a MCP batch I have launched, right? And there were 10 projects, right? So do one thing. Just try to watch only one project, only one, right? Only one, I think third or fourth. So in the beginning, I was not like, I just created the fast API. But yeah, just try to watch, I think third or fourth, any third or fourth project. It will not take much of time. You will be able to get a proper understanding. And going forward, you will not be afraid about MCP, right? Like I said, it's a protocol. It's a protocol. So whatever we have built, whatever tool that we have seen, whatever agent that we have seen, I'm not doing anything. I'm just trying to convert that. So for example, Flask API, right? Fast API or Flask API. What do? We have a method, we have a function, and on top of this function, so what we do, we try to bind it with the URL. This is the only thing that we try to do. Again, in MCP, same thing. So with the help of MCP tool, we try to bind it. And the exact same thing you have done even in a LangChain, even in LangGraph, you have done the same thing, right? So it's not very new. It's not very different. It's a protocol. Just execute one project, right? Believe me, you don't have to go till all the 10 projects which I have uploaded. You will be able to create all those 10 projects that I have uploaded out there. This is how easy it is. Just have to go and sit and do it. At least one, right? So I have created all the 10 videos, but even I'm not advising you to go through all those 10 hours of videos. No. Only one, because you are the part of this batch and now you are in a position to understand everything. So you don't have to like, again, invest that much of time. Let me take some more question. Master prompt engineering. Just leave it. Master prompt engineering. Just go to any GitHub repository and then download a prompt. No one can master prompt engineering. It's just like a human, like a basically intuition, right? So what you will do in mastering prompt engineering? These are the farji, things people used to spread. This prompt engineering, this, that. These things are not real. Great learning from the answer. Will keep learning from you. Thank you, sir. Do you have any example of cybersecurity in Gen AI? I have so many examples. Maybe just go and check Internship portal. Even over there, you will find some like a project. And try to build it with the help of Yuri. Looking forward to complete many projects as possible. Yeah. And guys, never underestimate AI. When you are doing any project, use AI, even though if you have to pay for it. The adoption rate, if you'll go and read out the latest report, so adoption rate in India is very high. right? Means everyone is talking about AI and everyone has logged in at least once, but the payment rate for AI is worst in India. Worse than worse. The reason is that people are not serious. This shows that people are not serious, right? People are not serious about like a AI. They're not using AI. They just heard about AI and they're just using some free tools, free sources from somewhere, right? And we all know that those free tool, free sources are not going to fulfill the real thing. And world is behaving just opposite to it, right? If you'll see that data from a USA, UK region and all those regions. So just my humble advice that try to adopt AI. Don't just talk about AI. If you are not doing it, for sure, it is creating a big concern. And for sure, the money that you are able to save, maybe $2, $10, whatever it is, right? It is going to hit you back badly. If you are into a IT segment, if you are into any segment of this entire universe now, even if you are a lawyer, even if you're a CA, right? I've seen, you keep on talking to everyone and I simply ask one question that, okay, how much you're using AI, like anything, maybe like a GPT or Cloud A or maybe Yuri or anything paid one, right? And I just get amazed that their teams are not using it. Still, they are opening up a document. See, I'm talking about CA and I'm talking about the lawyers, right? They are drafting still the contract, the same contract which can be drafted by AI just in a 30-second of time, right? And that too without any kind of a mistake, but still people are doing that. So, and these people talk about AI, that AI is going to take my job. Obviously it will take your job. For sure it is going to take your job, right? You will not be able to save your job. That's the truth. That's the reality. And as soon as we are going to understand this reality, we will be able to prepare ourselves for a future. So not just talk about AI, I would say, adopt it in your day-to-day life. Whatever task you are doing, use AI first. Try to look for a solution from an AI, right? There are like a cheapest version of AI, priced or like a costliest version of AI, which is everything is available to all of us. But yeah, the thing is, use it. Let me take some other question. So adopt AI, guys, in your real life as well. Don't just talk about AI. And with the help of AI, start building a project as much and as many as possible. Even as a learning partner, right? Don't look for your friend. Don't look after your mentor. Yeah, mentor means like, fine, like you are able to get overall concept. Now you're able to understand. Now, if you have to dig deeper, use AI. That's the reason. So I have integrated Yuri as a part of your ecosystem because I know that it's important, right? It's important. But if you're not using it, you will be at loss. Okay, that's I love every moment of it. Thank you, Eric. Santosh saying you have very good explanation style. Thanks a lot. You have learned ML from you now. This generate. Okay, thank you, Santosh. I want to learn time series analytics and reinforcement learning. Which courses? For time series, I don't have I have not published any specific courses. For time series today, I have done one project. So you can just go and do that project and then it's fine. So today in FSDS, I discussed one project with ARIMA and with a LSTM model for time series. For everything, I'll not launch a course. And I don't think that you should look for the course for everything. Looking for agentic AI class. Yeah, for sure. Are you planning to add the courses on a quantum in Neuron platform? I am planning for like a lot of courses, but the only thing is I'm the only mentor. I don't want to keep any other mentor. I just want to teach everything. Although it is going to take maybe next 6 months or maybe a year of time, but yeah, because I just want it. It's my like a very long-term dream that I'll go and I'll teach almost all the tech before taking a permanent retirement from a teaching, which is I'm not going to take a retirement by the way very soon, but yeah, I love teaching. So that's the reason. So I have launched like a 20 batches, and in every batches I'll start I have started creating the videos. AI on mobile devices, quantized model. I think I have published one shorts. I think reels. So where I have shown. Okay, so there is a Android app, and then you can download it, and then you can run the inferencing. Okay, so with that, hope I'm able to clarify all of your question. Hope all of you are going to implement it. You all are going to get an advantage from the entire Neuron ecosystem. Now you can go and you can generate your certificate, guys. Yeah. So certificates you will be able to click and download. So from your dashboard itself. And so start doing internship, right? Start using Yuri, start using a resume AI, start using a job portal. So what sort development courses are you launching? What sort of development courses you are launching? It's already launched, hybrid. Just go and check hybrid. Yeah, already launched almost everything: machine learning, deep learning, computer vision, stats, SQL, Python in Hindi, Python in English with DSA, then big data in big data masters, big data in Azure, then AWS, then big data with Databricks, then Power BI, then Tableau, then agentic AI or like a generative AI in cloud. Everything I have launched, everything. So for hybrid class, I will also ask, if possible, please create a project using poetry. What is this poetry? Like, not able to understand some of those. If you can rephrase it, maybe. Yeah. So with that, guys, thank you so much, all of you, and just try to build something and try to get into a better and better position, because that is how I'm going to evaluate myself as a successful mentor or as a failure. Yeah. So with that, from next week onwards, you can rest. I'm not resting because I have a lot of batches. I have launched like 20 batches. So I have to prepare a recording. Otherwise, you guys will start poking me on a group. We have a group, WhatsApp group, right? So guys will start pinging me that, okay, recording is not coming, because since last 2 weeks, so I was not able to, I was not that regular in terms of uploading the recordings, because last week we had a launch of internship portal, and then so I was busy from last week. So till last week, everything was updated. But yeah, so in last 2 weeks, so we had some like delay, not a big one, small delay. And I think from this week onwards, I'm going to cover all those delays. And then from next week onwards, we'll take a lead so that you will be able to get all the recordings as soon as possible. So you don't have to wait for the completion of like 2 months, 3 months. Please share the link for all the Google Sheet. So Imtiaz, what I'm going to do is that I think this week, by the end of this week itself, okay, let me tell you what is my plan and what I'm going to publish. So basically, we are going to publish a complete roadmap. So attached with the courses, Yuri, resume, everything. So something like this graph structure. So do this course and then do this particular course and then use this resume AI, this one. So in this way, then do this project, this project, this project. So this kind of a structure I'm going to release for data science, for machine learning, for deep learning, for computer vision, for big data, for Power BI, for generative AI, for RAG, for everything, right? Separate roadmap, a complete roadmap. And over there, mapping for the project will be done, mapping for the courses will be done, mapping for even books will be done, right? So that whenever you will start, you don't have to start, or even you have to go and search for the courses, right? Just follow along go to that page roadmap. Let's suppose you are preparing generative AI, right? Go to the generative AI roadmap page and then start tracking it from there. So I'm preparing it. I'm already preparing it. I'm already working on that. So beautiful, like a roadmap page with the attachment of this tree and graph, everything you will be able to find out. So in a smoothest possible way, without even asking for a roadmap, without even asking for a guidance from anyone, you will be able to move through it till a job, starting from the course selection, in between Yuri, then resume, then internship, everything, books, projects, everything, finding, because we understand that as the number of offerings is going to increase, it will become a little bit confusing, right? For all of us, that which one I should pick, which one I should not. So and we will keep on bringing more and more offerings. So we are not going to stop it, right? So we are going to bring more and more offerings. But yeah, at the same point of a time, I have to remove my students' confusion as well. So that will be released next week. It's already planned and we are already working on that part. So I think 12 or 15 roadmap, a different roadmap, you will be able to see it in a very beautiful manner. Believe me, you will like it, right? You will like it. And after that, you don't have to go anywhere and watch the how to do this or how to do that, or roadmap for this, roadmap for that. You don't have to follow anything. Just one place, and then, because that is the only thing which I believe is pending from my side. So just wait till this week, because I know that that's a real problem. And as the number of courses will increase, the problem will increase. I completely understand that part. We will miss the live session. Dave, don't worry about the live. So this time what I will do is that as of now, I'm speaking, I'm looking into your comments, and this is how we are doing a live, right? I have decided that going forward, maybe from this month itself, so in every 2 or 3 week, we'll send a Zoom link, right? We'll send a Zoom link and for a particular time, right? And whoever is available, come and let's have a discussion. So going forward, discussion will be even like more engaging. So even you can unmute yourself. You can, on your camera, and then we both can have a discussion along with other people. So that I will do in every 2 to 3 week, right? And that too with the Zoom, so that, you can talk. And then, because in this existing system that I have created, so this is for taking a live classes. So in live classes, because just to avoid my disturbance for myself, I have not given this unmute option. I can do that, but yeah, I have not done that purposely because I just want a little bit of peaceful delivery of lectures. But now I'll do it. Hope we will get a link over a mail. Which link, by the way? Which link? If you can tell me, I can clarify. Thank you, Sudhanshu. It's been a great journey. You learned a lot, given many interviews, and wanted to final our interview in 3 companies. Soon I will come up with. Okay, Amarnath, I'm waiting for you, man. I'm waiting for you. Yeah, just waiting for you. A Zoom link, I'll ping you in a group itself. So Zoom link. So like it is. There is no like a schedule I'm going to set. There is no like a proper time I'm going to say that, okay, this time or that time. We'll ping you in a WhatsApp group itself, and as and when people will be available, people will say yes. So maybe in a weekdays, maybe in a weekend. So we'll come together, we'll have a chit chat. So maybe kind of a informal discussion. Yeah. So that you will be able to get it into a WhatsApp group. Anyhow, we have a WhatsApp group. So I'm not going to keep it like a formal way. Yeah. So any other question for me, please go ahead. Please let me know. I'll answer. Super top. Okay. Thank you. I think I have answered all the question. I don't think that anyone is pending. I have been walking before 5 a.m. to join your live classes from New York. Thank you. Thank you so much, Imtiaz. Thank you so much. I know that like it's a lot of pain, joining from a different time zone. So really appreciate it. Yeah. And hope you are able to learn at least a little bit, not much, but at least a little bit from these sessions. Okay, so shall we end this lecture, guys? Today's lecture, shall we end this class now? Yeah, say yes, and then we are going to end it, and we'll see you again. Thanks for great work you are doing. Thank you so much, Ranjit. Thank you. Yeah. So, okay, fine. Thank you so much, everyone. Thank you so much. You were the wonderful audience, wonderful student. The only thing which matters is that try to get some sort of a success in terms of building, in terms of switching, in terms of getting a growth in a career. That's going to be a real success. That's part number 1. Part number 2 is world is very small. Believe me, world is very small, and at some point of a time, everyone needs someone. That's the reason. So I have created a WhatsApp group, so that all of you will be connected for a very, very long time. But that WhatsApp group is not just for connect. That is also for networking, right? That is also for helping each other. So, and actually genuine help. I know that sometime what happens in these groups are that a lot of noise, a lot of people, and then like a lot of unnecessary discussion happens. I truly agree with it. And we all can't avoid it in this world, in this digital world. But yeah, a person who is genuine. So try to maintain a friendship with those person. Help each other as and when it is required. Maybe today, tomorrow, or even after 5 years, right? Because the world is not going to end tomorrow. People will need people even after 10 years, right? And who knows how this relationship that you are trying to build now, today, right? will turn out after 5 years, after 10 years, right? So try to build that kind of a relationship. Believe me, you need a human being, right? You will need a help. You will need a assistance. Maybe not today, but maybe after 10 years, right? But yes, so the day you are going to need a help, you will not get it immediately if you have not worked for it. So try to build a good relation. Try to good relation, not in terms of just a talk, I would say, because that relation never lasts. So the relation which I always believe in is the fruitful relation. I'm doing something for you, right? I'm building something for you. I'm helping like in a real sense. Then I can expect that, okay, fine, I will be able to get help at some point of a time, someday. So try to build that kind of a relation. We have a beautiful group. We have a beautiful people over there, right? Use it and leverage it even after 10 years. Avoid unnecessary discussion, right? I don't think that it's worth of doing unnecessary discussion. And I believe in our group, people are very decent. So I think except one or two incident, which I have seen in my group. So in your group especially, right? Your group, I don't think that we had any kind of unnecessary discussion. So people are literally very genuine, very decent, right? So maybe you can connect with them personally, not in a group, right? DM them. But don't try to bug them unnecessary. Again, otherwise they have an option to even block you, right? So that try to build a strong friendship, a strong relationship, help each other at the end of the day. That is something which matters, right? Then you will be able to remember Euron for a very, very long time. That, okay, Euron was the reason, we are a friend, and now we are helping each other. Yes. With that, thank you so much. I'll keep on building new things for all of you. Service, project, goals, everything. And yeah, see you again. So thank you so much, everyone. Take care.